Okay. So I don't think software engineering as an interdisciplinary study should be influencing anything that our architecture looks like, right? Like it's not going to change whether how we space our columns or how people interact with our building. It's more about affecting the process in which we design than the actual output. It might that might affect the output, but it doesn't necessarily affect like function and form. So what what we may see is things other than the traditional sense of art starting to influence that. What do these images look like they're from?
Okay.
Yeah, a video game, right? Yeah. How many of you play video games? What do you play? What don't you play? No, we do. No, because you're going like this. So, huh? Slime Rancher. That's a game. That's a video game. Yeah. Okay. So a lot of you guys are actually interacting with art, but in a very different way to the way that people used to interact with art, right? The amount of art that goes into video games and uh like social media content, because that like YouTube, you guys watch YouTube, right? More than you watch Channel 9.
Ew, no.
Huh?
What's that?
Yeah, ooh, right? Unless you're watching the Olympics, right? Yeah, you're watching stuff off the internet. That that is now becoming the new norm of the way that you guys ingest art. And so I thought, well, this is kind of like where people are being influenced now in terms of art movements. So let's go and take something that's quite strong in that, something that has a grounding in literature. So a lot of this stuff has come from the writings of 60, 70 years ago. So if you look at like Jules Verne, that is very much like the the beginnings of steampunk. And if you look at Philip K. Dick, he's the guy that wrote Do uh Androids Dream of Electric Sheep, which eventually became Blade Runner. That's starting to influence all of those types of science fiction in media, and you've got then directors and art directors that are looking at that literature and putting this really engaging aesthetic on it. So this is very much aestheticism in a real condensed sense. It is taking a a technology or a philosophy that existed in time. So it is very much about looking back on the world, looking back at the 80s or the 60s or the 20s or the 1800s and saying, okay, what is it that made that era what it was? And what we're going to do is we're just going to just juice it up, like put it on steroids, absolute steroids. And let's not just put the aesthetics on steroids, but the philosophy and the technology and all of that. So steampunk assumes that steam is capable enough of actually running a society with this many people. Can you imagine having almost 9 billion people on the planet that are actually working off steam tech? It's not possible, but in steampunk, it is. And with that, what we're going to do is also celebrate the idea, the architectural and design aesthetic of the Victorian age. Now, this can be quite insulting to historians. So I'm just saying, like, you will see people like potentially Jennifer getting a bit annoyed at that you've maybe taken the idea of the Crystal Palace and turned it into something completely different. And it could be insulting to the cultures that we're juicing up. So if you really wanted, we could maybe play around with the idea of like dreaming punk, right? You know where I'm getting at.
I don't know.
Like, so you've got indigenous, the dreaming. So, um, the very much the tech, I'd say the technology that sort of sat within tribal Australia was this verbal. communication, and they call that the dreaming, and it's very much about communicating that. I think maybe we won't touch on that, but if you want to, you can. And we'll see what Marnie and David say. Um, but it's very much about pulling that aesthetic through and layering that onto your architecture. Okay. Now that's the fun bit. Hopefully the coding will be fun, but it's going to be hard. So we're going to learn the fundamentals. So you can probably jump on the internet and find a whole list of different punks that someone's already come up with, right? But I don't care what the world says. If you want to sort of say, hey, let's look at um the 16th century and let's do some kind of like Renaissance punk type thing. I'm totally happy for you to, or the 16th century is Rene. Yeah, yeah. Like I'm totally happy for you to do something that doesn't exist within those predefined fictional aesthetics, because this is a place for us to experiment and have fun. Cool. Okay. We'll get into the more punky stuff later. So who doesn't have a group? One. Okay. One, two, three. Hang on. Hang on. This is gonna be hard. Okay. How do we do this? Those of you who don't have a group, can you just maybe at the end of today, I want you to come to me and let me know. Let me know what your punk might be. Okay. And then I will facilitate the team if it needs to exist. Cool. Okay. Now, so where are we? Course outline. Oh, we should talk about the AI stuff that Jennifer also spoke about. We will be trying out AI later, um, in the second half of the course. Okay. It is an experimentation environment, and we're not going to just jump on mid-journey and type some stuff in and get some images. What's really interesting is that the AI side of um, the AI rules applied to the uni, what the hell, through the uni, I think is very much targeted at text. Like it's very much like, hey, we don't want people writing essays, right? Um, I I would find it very difficult to get an AI to actually generate something that I could use within my design studio. Like it would be like having a completely different building in every image, right? If I actually sat down and said, okay, let's generate some AI images, they they're not going to be consistent between so so an elevation versus a section versus a plan versus your 3D renders. If you just rely on AI and try and get by with that, it just doesn't work, right? So you're actually probably making it harder for yourself by using AI for architecture than easier. And if you were able to use AI in that sense, you're actually able to harness it and use it in the current state that it's in. You've done a much better job than anyone else in the industry could have, and you deserve the mark. Okay? You deserve that mark. So I'm just letting you know now that going that direction is difficult. We are going to we are going to download open source AI packages, and we're going to use them to apply style to images that we've already produced. Okay. Um, so that is one thing we would be doing, and we'll also be talking about generative design, because this AI AI thing has actually been a massive argument within architecture for a lot of years now because we've had generative design. Is generative design design? Is generative design architecture? Can you honestly say that you did the work if it was generatively produced? That's been around for ages. Now, other industries are having to ask that question about text that has been generated within their profession. So we've actually got a quite mature approach to generative design, so and generative processes. So we'll be talking about that later. But I'm more than open to people using things like Midjourney for idea generation, very similar to what Jennifer mentioned. I guess the university said like you can use it for creative discussion or learning. And the real interesting one is for like precedent, right? So do you guys interact with like using precedents at within the presentation, or is it something that you avoid, the uni avoids, or at least the culture here avoids? Do you know what I mean? Like if I'm like, hey, here's my I would like to do this type of I would like to create a stair or let's say a room that has this real sense of ambiance with it with the natural light, right? I want to play around with phenomenology and I would like natural light to come into the room in a really engaging way, not just as a window. And because it's really hard for me to communicate that with words, instead, what I'm going to do is I'm going to go grab Tato Ando's Church of Light, just off the top of my head. That image is a precedent that I can say, okay, this is done really well, and we can look at how it's done well, and I can put that into the narrative of my presentation and slap that up on the wall. As long as I attribute that to Tato Ando, then do you guys do that? Okay. So Midjourney can kind of we can kind of get ideas like, hey, I would like this type of thing. Like I'd like a room that engages with light, and we start getting images that way, and that could inform the output. The only danger with that is it's just not built, right? It's not real. So whatever is actually being produced by that as a precedent isn't actually a working precedent. So that's the only danger with that. Okay. Okay, I'm getting off topic. Where are we? Does anyone have any questions before I move on to the next part of things? Cool. Okay. So we are going to be doing these things called coding workshops, which are going to be a little bit different to how studios have been run. It's going to be more like, I guess, how you learnt Revit, where you all sit around and you follow a tutorial, like a workshop. We're going to be running those every week. Um, and then as we get into the second half of the semester, those are going to become a little bit more experimental. So we're going to be dealing with fundamentals to begin with and experimental later. And aligned with that is, I think, a fundamental design exercise, which is designing a stair. Very focused. I don't like we don't have to break the any molds or play around with too much function. It's really about taking those core concepts and applying them to a single beautiful, maybe even ugly thing, right? And then you guys can hopefully take those fundamentals and some guidance in certain directions for experimentation in the second half of the semester, and you design whatever, as long as it's entertainment related. Okay. And so I chose entertainment for lots of reasons, and I mentioned that in here. But a really good one is like you can actually put something together that's entertainment and slap cyberpunk on the side of it, and it still works, right? So that's you don't like it's hard to have a cyberpunk hospital. right? Who wants a suburban hospital? We don't want that. Apart from the tech, but apart from that, yeah. So that'll work. Every other class is going to go out on a site visit. We're not. Okay. I'm going to be supplying you guys with real world data that we would be collecting on projects, and we're going to interact with those sites via the computer. So that way you can actually get some experience with that prior to actually going out and getting a job and getting that information later. The critical ones are like LiDAR point clouds. People, for some reason, don't get taught about them, and then they get hit with them. No one knows how to use them. So I'm going to give you guys some point clouds. I'm going to show you where you get point cloud data as well. And then um, we will be using those and other means to sort of scope out our site. Um, this is really a role playing exercise to how Danielle and I sometimes have to interact with sites. Like, Danielle, have you ever been on site? So yeah, so I work quite a lot internationally, and they don't pay for me to fly international to go do a site visit. So I have to gather my information in other ways. So it's about that. I think it's a bad thing. I'd love to get flown out international to do a site visit. But uh that is unfortunately how the world works. And so we're just going to role play that. Assignment 2 starts week 7, which I think is bullshit because it's actually week 7's week 8, right? Because um there's a public holiday after Stuvak. So what that means is for a course that is very much about you spending time outside of class, there's going to be this massive gap of time that you aren't doing anything from week 6 to week 8. So I've decided I'm going to introduce you guys to assignment 2 on week 5. Okay? So that way, if you want, you can work on it during that time. Cool? I we have we have been told that we can give you guys an extra lesson in that time that isn't on a Monday, and we'll get paid for it. What we as we get closer to it, we'll work out what we want to do. But if we can just find a time, maybe we can come back here, like on a Tuesday or some day in the week of week 7, and we'll just do this class on that day. As long as majority of people are happy with that, we'll we'll do that. Does that sound like a good idea? Do you want to organize that now or maybe next? What I'll do is I'll find out the schedule for this space, so when it's available, and next week I'll come back and we'll decide it next week. So that way I'm not ruining holiday plans or, you know, those of you who are probably all doing shift work know, when you have to take time off. Yeah? Does that sound good? Yes. Is it? No. Is it?
Because the public holiday is later.
I'll look into that. Either way, if it is, it doesn't ruin anything. Okay. If it is, then that changes everything. Cool. It changes everything as in I can at least introduce assignment to week 7, and then you guys have something to work from during that break. Because that's I feel like yeah, most of the learning happens outside of class. And so if you're just sat there doing nothing, which I probably you guys I'd go insane if I had nothing to do on my Stuvak. So it's really up to you though. Okay. Have we missed anything else? Oh, okay. Another thing. You guys are all master's students. You should be capable of working out how you need to communicate your design by now, right? I hate putting requirements that say I need a plan, I need a section at this scale, I need a particular model, right? You need to be able to decide how you communicate your design to me as an audience. Not just me, whoever the crit people will be. And I probably won't have guest crits, but there will be roving crits, right, during those presentations. So that's if we go now to assignment one, wherever it is. Here we go. So communication of architectural design is that, right? You've got to communicate your design. You've got to consider the story that you're telling. Do you feel like I need to talk about like architectural storytelling or can skip that? Yeah, should know it. Skip it. Okay, cool. Um, I'd like to see precedents for your technopunk. So go and look up go and find the history of that particular technology or era that you're playing around with. Get historical, like be a historian there, but then also have a look at what what the punk aesthetic is and let's discuss it. Um, and then we will talk about pseudocode. Okay, so I'm going to be running us through a bunch of coding exercises over the next few weeks. Part of those, I will be doing what is called a pseudocode. It'll be at the beginning of each process that I will talk about what we're about to do. It's like mapping out what the process we're going to follow is. We don't have to follow it intrinsically, but it is this pseudocode is a way of coding without code. It's like just mapping out process, right? So, um, a great way of thinking about it is okay, if I'm gonna draw a cylinder, and I just need a whiteboard now. If I'm gonna draw a cylinder, hang on, I've got a computer. I should be able to do it. Um, the first thing I have got to do is pick a point where I want that cylinder to be, right? So that's I don't need to be able to code to be able to identify that as part of the process. Then I need to draw a circle off that, and I probably when I do that, I've got to decide the radius of that circle. And I'm also now deciding the direction that cylinder is going to be drawn in by drawing that circle. And then I'm going to extrude that in that direction. And that's when I also decide how how tall that cylinder is going to be. And there's a third thing I'd probably need to consider is whether or not that cylinder is going to be solid or hollow. But that being able to identify that verbally and talk out that process, that's pseudocode. Okay. So we're gonna we're gonna be talking through pseudocodes prior to every code. And I also would like you to consider how guys actually go about doing your processes, be it working as a team, be it what you're designing when you go to put your pen on paper, just draw out a little pseudocode. Okay. How am I going to like how do I do this? I iterate. Like I come up with an idea, I sketch something, and then some people, I don't know why, but they draw it again, and then they draw it again, and they draw it again. That's their process. Draw just a little pseudocode diagram of how that works. If once you get into that process, it we would like to see that mapped out for your assignment one, like what your process was or how you went about doing it. That doesn't have to be in the presentation. It can be like a side thing, but it would be really useful, especially how you're working as a team. So I'd love to see you guys are working as a team. I don't know how you're going to do it, but I'd like to see it. And if it works, then I'll take your pseudocode and try to apply it somewhere else. And then um, your design. we'd like to like the design is the design is the final artifact. It doesn't necessarily show your process, right? It's like I think I probably said this in the video, but I sometimes find it more enjoyable watching how the art was made than actually the final piece of artwork. I think one of the big ones was the like Pablo Picasso's um giant painting. Uh this one. Guernica. When I saw this piece, I just spent the whole time watching the video of him painting it rather than looking at it. It's just me. That's just who I am. But I'd this is going to be a celebration of the process. Hence why my lecture in week 7 is process. So this is a celebration of process as much as the final artifact. Okay. So I would love, I don't know why this is crossed out. Boop. Demonstration of how your scripts work within the final design. And that can be supported by the pseudocode and any working files. So basically, you're going to be submitting your portfolio, this thing, with all your assignments anyway. Like you just collect it. It doesn't need to be presented. It doesn't have to be in a little PDF or anything. Just a folder full of all your stuff. Just send it through so that if there are things that are failing, we can go in and see them and see how you think. Because Grasshopper encoding is very much us being able to see into your brain. And what does my brain look like? Yes. A complete mess. Okay. GitHub. I really need a whiteboard. Are you regretting the decision yet? Let's leave it there. It's fine. Okay. So GitHub is already going to probably intimidate most people here, because I've seen it break far too many architecture grads' brains. So I'm just going to talk you guys through it, so that way you're right. Watch out. Watch out even more. This is blue. Oh. Anyone called one? No? Okay. Okay, let's just try this. So GitHub is a server that runs this thing called Git. Okay. Git is a versioning control software. It is predominantly used by software engineers, and it is going to keep track of changes that you make. What it does is it actually keeps track of every change that is made and saves that as a version. Okay, so if you really want you can go back, like if you fucked up a lot, you can go back a day and get the previous version and just go from there. Okay. It basically, rather than sort of saving it like this, it saves it like a branch where people can actually take elements of the main pathway, the main branch, they call it. You see the word branch, and they can either fork it. So this is called forking, or they can just work on that main branch. I think for you guys, we're just going to avoid forking, okay? But if you need it, you can look into it. What forking does is it makes it a little bit more of a process to merge things back together. So this is a branch called main, and we'll say these are like the main branch, right? What I could have is I could be working with Danielle, and Danielle is working on the main branch, and I could fork my own branch. And I can name it whatever I want. Danielle can technically name hers whatever she wants as well. I work on that. I work on my branch, and she works on hers. And then eventually, when we're happy, we merge them back together. And that, when I fork something, is called a pull request. I think this is probably the reason why GitHub is so confusing, is these terminologies, right? So that's a fork, that's a pull request. When a pull request happens, the system looks at what's changed and if there are any clashes. So if Danielle has worked on a file and I've worked on a file and they're the same file and they don't line up, then it'll tell us, hey, these things don't line up. That's when, with Grasshopper, things get fucked up real quick, okay? Because Grasshopper doesn't allow us to quickly check how things are different and merge them together. So this is what I'm trying to avoid this. So this is going to be really complicated, isn't it? Okay, we'll work it out. Okay, can everyone see this? It's making, like, even though it's blue on red and cool. Okay. So this is very much like a library that you can edit, right? You've got a library element that you take elements out of. And you're actually looking at your own version of that library. It's like a carbon copy of the library. To get that, the terminology for that is called a pull. And then when you go to take out an item and edit it, you get ownership of that item. Okay. This is very similar to how Revit's starting to work now. So those, like, you guys were syncing in Revit, right? And did you have ownership issues in Revit? No. Okay. Yes, you have. You've had ownership issues in Revit. Yeah. Okay. You're the only one. You've had them. So anyone else had ownership issues? Like anyone actually been told someone else owns this in Revit? Okay, I'm only getting 4 nods. Okay. For most of you, you're going to eventually work in Revit in the industry, right? So we might as well turn this into a Revit lesson. This is called, huh? No. Huh? It's the, you know, the one we just download? Refresh, it's refresh. Huh? No. Why can't I remember it? Let's put my tongue. Yes, that's it. Okay. This terminology in Revit, so pulling from that central library, is called reload latest. You'll find that in the collaborate tab. Yeah? You'll find that in the collaborate tab. You're right, but I was looking for the specific one, right? What this is doing is it's downloading all of the latest information that's in the library into your version of the model. Yeah? And it's the same thing that GitHub does. If you take a book out of that library and begin to edit it in Revit, you gain ownership of that book. You own that book, right? And that's why in the future, when you're working, if you edit something, you own it. It will send a message back to the library, to that base model, set the central model, and tell people, hey, no one else can edit this, right? So when Danielle comes to edit that book, that element, it'll say Andrew owns that. And what do you have to do to get ownership of it? I've got to send this back to that central library. So I've edited it and I'm sending it back. GitHub calls that a commit. And Revit calls that a sync. And for some reason, Revit actually, when it calls sync, by default, it actually does a reload latest and then does a sync and all of that type of stuff. And generally, that is when Revit will find issues within the model and any changes that you've made and throw warnings up. Okay. That's also when GitHub will throw those warnings up between you and your partner. Okay. This is not a silver bullet. It will protect you. Okay. So if there are issues, you can always go back and see things in the past and try and fix them. As long as you are syncing or committing regularly, then that will work. But the instant that you have a clash between two files, GitHub will throw up an error, Revit will throw up an error, and then it is on you to fix it. It's not going to fix it. Okay. So you guys are going to probably run into these errors in GitHub. Okay. I don't want you to freak out. I want you to record it and put it in your portfolio. Okay. And learn from it. Yeah. So I'm going to show you how this works in a second. But the terminology that we're going to be using is pull, commit, fork, and pull request. Cool? Okay. So GitHub has actually made a nice tool for us to it makes it a lot simpler. So what you want to do, are we all on Windows? Cool, except for you. But you're still running Windows, right? Okay. Oh, this is so good. Normally I have to like depress a whole bunch of people. Oh. Huh? Sorry. But you're running Windows on there, right? Okay. Okay, things are getting a bit harder later on when we start playing around with things like Unreal. So have a look at getting like how you run Windows inside those laptops, okay? Yeah? Huh? It will only make it slow when it's running. Yeah? It's not going to like permanently brick your laptop. Okay. So you can grab, if you type GitHub desktop into Google, go download, now that you've got a GitHub account, go download the desktop version of the desktop client of GitHub. Oh, one other terminology, this central library that I was talking about, that is called a repo or repository. So you guys are going to make a repository together, and then you're going to work in that repository um, by pulling and committing or forking and pull requesting. And I sound like I'm going crazy saying that. Um, weird, but eventually we're going to start talking about animals. So, like grasshopper and rhino. I wonder what I left on my screen. Okay, so you guys have all made a GitHub account. What I'd like you to do is create a new repository in that account. You can do that on the website. GitHub. Oh, no. And I'll do it here. Are we still recording? Yes, good. Pardon? Yeah, it really should have been a warning at the beginning of the like Revit doesn't work on Mac. Yeah.
We're gonna create a new repo
Yep.
on the local road.
You're using the desktop version then? Okay. Let's I'll make one and you can follow. Okay? Yeah, but we might as well get everyone to make one for now. Public? Doesn't matter. It depends on what they want. I'll mention it in a second. What am I doing? Ooh, I don't want to change my password. Mm. I think I know. Okay, now you guys get to watch me put in a new password. That's not good. How about I do this? Stop share, and let's see how quick you guys are. Did you catch that? Nice. Hey. Okay. Okay, so you logged into GitHub. Yep. Um, your GitHub should look like this if it's just a base, like if you go to github.com once you've logged in, you can create a new repository here with that little green button. Oh, I'm gonna share, go back to sharing again. Just go back for those who are watching. So you click new. The owner is going to be you, unless you have some other account with GitHub, and then you can choose whoever. You can type the repository name, so name it whatever you want. For the sake, for my sake, just put your name on it, because otherwise, when I go to look at it in my folder structure, they're all going to be called Mark 510 or whatever. So if you could just put your name in the repository name, that would be great. So here we go, Andrew B. That's enough. Mark, what is it? 510. Um, it's going to give you a choice between public and private. It If you make it public, I will be able to access it without you giving me permission to see it. If you make it private, you will have to give me access to be able to see it. So make your decision now. You can always make a new one. You don't have to use this one. You can always delete this and make a new one. You can always change it from private to public and public to private later as well. But that's really it. Um, and then the rest we can just kind of skip over these for now, and we'll create the repository. Actually, let's add the README and then create the repository. And you can see here this will set up main as the default branch, which is what we want. You good? Yeah. Yeah, okay. Yeah. Yeah.
That thing, do you have to keep doing it?
No.
Every time if it was
Once you've given me permission, it's done.
custom.
Unless you kick me off. Pardon? No, no. So the .git ignore is it's a way for you to have files on your local machine that don't get uploaded. So you know how you have like I'm assuming you guys have all used Rhino. You know how Rhino has that Rhino back file in your folder, in the folder? That file you probably don't need to upload to a repository because it's just like a little backup file. So you could say ignore Rhino back files in that in using that .git ignore system. You can plug into that. Go for it. You want to have a go? Oh, it's put on the zip tie. Yeah. Um, I'm gonna move soon anyway, okay? Okay. So I've got a repository. Now if you run GitHub desktop, so has everyone installed that? So within GitHub desktop, yours will probably be blank compared to mine. It might even be like, hey, do you want to start a new repository? Because it knows you've got nothing. Um, if it maybe just hit cancel. So it looks like this. We can create we can create a new repository, which is not what we want because we've made one on the web. What we want to do is we want to clone the repository, which is another term that I should mention. So this thing here, so this version of your library, that's the repository. That's repo. This is the clone. Cool. Which in Revit, that's your central model, and this is your local model. Cool. Revit doesn't explain this to you, by the way. It all happens in the back end, and when it breaks, that's when you need a BIM manager. So if you guys start to understand how that works, you might become a BIM manager, maybe, or B, you don't need a BIM manager. So that helps. So we want to go file, clone repository. It's going to give you a list of all your repositories, but it's also in here that you can start to clone other people's repositories that have made them public. So if you eventually, when we start playing around with AI stuff, we're going to go be borrowing other people's AI code. We're going to be doing that with GitHub. They've made it public, so we can go clone their work and start using it. But in this case, we want to pick the one ours. So I'm going to type in the name of mine. There it is. And yours should be in that list. Won't be as long as mine. And then you can also pick where you want to save your file, this repository. I'm going to chuck mine in downloads. Just by the way, if I'm going too fast, tell me, okay? And if you're worried that you're the only one that is lagging behind, grab Danielle, okay? Cool. We'll clone that. That's fine. Okay, do you want me to repeat? Where are you up to? Perfect. Have you got GitHub Desktop? So you open GitHub Desktop. So in that, we want to, is there a thing there, option that says clone? In that list. Oh, sorry, I've forgotten a really important step. In GitHub Desktop, you probably need to log in, right? Have you done that? Have you logged in? Okay. Who's not at this point where they've cloned it and they'll be seeing the name of their repo up here? Yeah, I guess. Oh. No, you're logged in. So it's Gmail and 64. Hey. Oh, and you pick where you want it. What? This is not a typical studio start, right? Hey, maybe we'll have a break and then we'll go look for some way to clean the whiteboard because I'm going to need it. Okay.
Sorry.
Huh?
We've been there for ages.
I know. Yeah. We're bringing a new whiteboard next week. Yeah, but really?
But I don't know. It's what average.
Oh yeah. Yeah, it's that Microsoft thing, isn't
So
it?
I could do this. Okay. Is there a
Is there like a mode you can put it in?
yeah, that
I've
doesn't
never used this.
yeah, hang on. I can do this. No, it's not. Okay, so it doesn't feed back to the this. Okay, whatever. We'll work it out. We'll work it out. Today we're just introducing you guys to stuff anyway, so it's all good. Boo, boo, boo. So you should be able to find a folder where you you chose. So in my case, I chucked it in my downloads. And that will have a little Git folder, and if your computer is set to hide things that are hidden, then you won't be able to see that little Git folder. And then if you chose to make the README, it'll have that there. Or if you didn't, it'll probably be empty. Okay. I'm gonna just quickly make a new text document and just write hello. And what we'll be able to see in the GitHub desktop display is that it has seen that one file has changed. And in this case, there's a new file called hello.txt. Cool. Um, you good?
Yes.
Do you wanna
Yeah.
is that better? Cool. So I've got hello.txt there. Why not? Let's just whip open Rhino and
Wait.
huh? Pardon? We can use Rhino 7 for the first half, but Rhino 8 for the second. Is that okay? Pardon? You've already used the free license?
The uni just gives us 7.
Okay, so what you can do is for the second half, you can go get the evaluation version of Rhino 8. Okay? You'll have access to it for 90 days with the email address that you use. Okay? You'll see how awesome it is and then decide to use it from then on. So the uni's giving you all access to Rhino 7. Oh, that's really cool. That's awesome. Before you graduate, buy Rhino. Okay? Because it'll cost about $300 if you buy it now. You'll get a student version, which will immediately become a commercial license when you leave uni for free. Okay? So if you buy it after you graduate, it'll cost about $2,000. Okay?
Right.
So buy it now, or at least before you graduate. You've got to prove that you're a student when you buy it, and then you'll get it for that $200 to $300. Okay? So good tip. Then whenever it gets upgraded, you have to pay. So you have to pay to go from Rhino 8 to Rhino 9 and Rhino 9 to Rhino 10, but the upgrade cost is almost equivalent of just buying it as if you were a student. Right? So you're much better off buying it now than you are in a year or two's time. So yeah, don't just be careful with that, okay? Cool. I I bought on my versions when I wasn't a student. So it was that was a lot. Um but so we can use Rhino 7, but we're going to be playing around with some fun things later on in the term, in the semester. And it would be cool to play with Rhino 8 instead of Rhino 7. Cool? Cool. Do you guys get Rev? You guys got Revit, right? So we're gonna be. Maybe I'll do this at the end, but um, I'll talk through all the software that we'll be playing with maybe at the end of today, so you guys can go off and get it. Most of it is free. Yeah, the only thing that won't be free is Rhino. Uh, yeah, that's the only thing that won't be free.
You know that 9 day thing you're talking about?
Yeah.
Or Rhino 8? What if you already got Rhino 7 paid for? And
You can still get the Rhino 8 evaluation.
Oh.
Yeah. Okay, so I'm gonna make a grasshopper file. It's gonna be empty. I'm going to save it. I actually can't save it unless it's got something in it. Um, and I'm gonna save this as two different files, and you guys can see where the issue is and why we have to change a little bit. Where's my downloads? So this repo works like any folder structure, so you guys can organize it how you want. You can put folders in there, and you can put shortcuts and they'll kind of work as long as they're pointing to the right thing. So I'll just save my unnamed grasshopper file in there. And then I'm also just going to make another different version. And rather than picking .gh, I'm going to pick .ghx. So GitHub can see those. If I click on the unnamed .gh file, it tells me this is a binary file. It's changed, but it can't actually look at what's changed because of the file type that it is. Okay, it's a binary file type. So that means if I open that up in a text editor, which I will, I'll show you what it looks like. That's what it looks like in a text editor. It's completely unreadable by not only a human, but also unreadable by any other program other than Grasshopper. Okay. The GHX file is readable by a text editor, right? It's in this thing of a file format called XML. We're not going to be looking at XML and just saying that's what it is. So don't this is not the level of coding that we're going to be doing, but it's text that is describing what's in that Grasshopper file. So when you have made changes and you want to push them to the main branch, you need to give that a name. So I'm just going to say initialize or start just to make that human. I can even write a description. This is the start of Mark 510 5010 5020. We can even add co-authors if you've been sitting with me and we've been working on it together. I can say, hey, you've actually helped me write this here. And then you commit that to main. What that does is that puts that in the chamber of the gun, the GitHub gun. It's still not in the repo. It's just been committed. What we have to do is push that back to the repo, and that's with this little button here. This button up here is what you will use to pull or push information to the repo, and it will tell you what it's going to do. So here it's got a little symbol that says 1 push. So it's pushing 1. If there was information on the repo that I needed to download, it would give me a 1 with an arrow down as well. So it's telling you what it's about to do. So, fire the gun, push that off to the repo. You can do it yourself.
Was it published, right?
Oh, you've done something different. But yeah, just publish it. Yeah. And I should be able to see. I'm actually on two different computers at the moment. No, I'm not. I'm not on two different computers. I should be able to see that change. There we go. So there are those files that have now been uploaded to the repository. Cool. Now I'm going to make a change to one of them on the repository just to demonstrate what this looks like. You can, so this file's empty. The blame icon on these is their way of like someone writing like this is like putting an error or saying like, hey, this has a bug or something like that. So you guys don't have to use that to communicate with each other, but you can if you want. And if you want to download the file raw, that's this button, but there's also this guy here, download raw file. In this case, I'm going to edit this because it lets me. Hello, commit the changes. All the different options that was on the GitHub desktop is now here. I have to put a name and a description for what I'm doing, and I can just say, hey, commit that directly to the main branch. And what I should see in GitHub desktop is if I refresh this little guy here, it will tell me that there is a change on the origin branch, and that I can pull that to my local version of the repository. Okay, so I run that, and hello.txt, has now got that little hello in it, right? Cool. So what this actually allows us to do is if I make any changes, and all I'm going to do is I'm going to move this component in Grasshopper and resave that file. GitHub Desktop will recognize that that file's changed, and it will also tell us what's changed. Okay, it's probably going to be unreadable to you, but just by looking at this, you can see that it's detected that this component's X and Y coordinate has changed, right? That's all I did. It's a few things have changed, like for some reason the image has changed. That's the image of that's the thumbnail of the script. So the thumbnail of the script has changed, but that's all that changed in that script, right? That's going to have my fingerprint on it. It's going to have Andrew or Sefbin, which is my account username. Sefbin made that edit. That is this is how you guys are going to work together, but you're going to do individual work in a way, right? Cool. Is anyone freaking out about GitHub at the moment? I think yes, everyone. Good, good. Okay. So part of this is please, like, if it's not working, just come back to this recording, which I will put up. Follow through it again. If you're freaking out, I want you to just remember that this is a learning exercise, and I know that this is part of what you are learning. So I'm going to guide you through it. Okay. You're not going to fail this course because you can't get GitHub to work. Okay. We're going to get GitHub to work. And you're going to start, and you hope maybe start thinking about thinking things through like GitHub. So you were the first person to put your hand up. Is it working? Okay. So this is how you add a collaborator, by the way, because this is the next step. If on the web page, if you go to settings, it's this little cog. Are you on the web page? You got settings? Cool, cool, cool. And then in settings, you will find, where is it? Can I just go to the normal zoom? Up here. You'll find collaborators on the left menu. And what you can do is you can start adding collaborators there. So you can add your colleague's name there, but you can also add my name. So if you add people, I'm gonna get spammed. But you can put Sefbin. You can just use SEPHBIN and hit. There'll be a list of those. It'll be this little guy here. That's me. Yeah, add me. Cool. I'm gonna get a little message saying 1,000, or not 1,000. At least. Okay, which one are you? No, none of these. Uh, pardon? Am I in what?
Is it Teams?
No.
Or Chrome?
Here we go. Okay, which one are you? I've got yours. Huh? This one? No. This one. Cool.
Oh.
Yeah, it's working. There's hello text. Can you make an edit to hello.txt on your computer and commit it to the repository? Yeah. What? What name? Ah, it is. Can you read that? Yeah. Hang on. And it will have like a little pixel version of me, but without a beard. Cool. I'll go through and accept all the invites later, okay? But so you're in the middle of committing. You've got to type. How many files have you edited? Are you sure? How many files do you have on the left here? Two. Okay, guys. If you make changes to multiple files, you have to type in a name. You can't just rely. You have to type something in the name there. So type something in. There we go. And then remember you got to hit this button as well up here. Cool. And I should be able to see. So 8 minutes ago there was a change, but if I refresh, there was a change just now, and I can see ArchiPunk editing. Cool. It's working. Yeah. It will make if you use the GH files, it'll still make the change, but it won't be able to know what changed. It will only just know that there was a change. It's up to you. It doesn't matter. But if we use GHX, that we can play around with things. Like if you have a clash, we can actually merge that clash. Whilst if it's a GH file, we can't.
That's how it tracks.
Yeah.
Yeah. I'm wondering if someone will invite me to how do I approve?
Okay. So you can do this. So someone's invited you. You can go to your unread notifications up here. So this is your inbox, and there should be a bunch of messages there, and you'll have your invite in that list. There was a question at the back. What was your question? Oh, just it's not working? Okay. Okay, so you've got to write a summary of what's changed. Start, and then we can do that. And then you've got the. You should go to one. Yay! Getting skeptical looks. Real good. Real good. Why? What's up?
I want to push it out.
Oh, this will all work the same. Okay, so you.
How's it work?
Yeah, start text.
Put it back on the
No result. I don't know result. I didn't send in.
Yeah.
Harry.
And then save.
Yeah, it'll show up there.
Save it into the folder. That's what it is.
If your friend, say your is your you can also put files on her computer and she'll push it through and it'll show on your web browser. And then you can pull that stuff into this. This is the way of collaborating.
And then GitHub.
SEP.
So when you
When you find out where you are, like this folder is
Alienware.
how do you know where you are? Like even Windows, press
我之前是那种学一下拍的，
training is
然后是
the location where I'm in.
yeah, which is commit. Okay, commit is step one, and then commit is kind of pass it.
So you go into two. Where's the which one? Which one?
The little inbox.
But then that's that's what you change. Okay, so the one that's down.
What? Yep.
Drag that.
哦，有一个人看了我，
我会看到这里了，
See how it's solved.
有没有看到？
张国庆，
女生在那个
Well, you can delete this.
我考虑人。
And then you can fit into that box. Yes. Yes. But that's
Yeah, I think
Yeah. So what's the lead? And then you make it. The system saves and changes.
怎么跟他们打开有那种，好像从这里
You've got like a giant invite file, can't do that. But usually like everything's working. You don't need it. We're only using, we're using this as a way. You don't need to use it.
在这个里面，
Lunch. Okay, so you want to have a break? Huh? Yeah, there's no lunch. But you can do it now. We'll take a break. Take a break. Yeah, we're gonna have a break now. So if you can go grab a computer, go grab it. If you want to go do something, when we get back, we will be coding, we'll be doing some grasshopper stuff. Okay? Cool. Thanks. It looks fantastic. Okay. You went around the wrong way? Whatever you want. So
like a summary is.
I usually use GitHub because
Yeah,
it's
apparently I'm waiting your response.
I'm not always collaborating with people. So like, sometimes I don't even take description. So it's up to you. It's up to you how you what you do, you save to local, and then if you want to put that your collaborator. That's
Not yet, but
that is a backup. That's a backup.
So you can do it anyway.
Yeah, that's useful.
Okay. Thanks. What time are we?
Just sorry, what's Amy, how long do you think you'll be? Half an hour. 20-minute break. Yeah. Cool. Hello. Yeah. yeah. See that? Just for now, save your and then it will make it easier if you change that to do that later. Yes, what I'm going to do in this 20 minutes, we'll try to reorganize this so that we're looking that way. Cool?
You're the best.
Yeah, it's there. What are you trying to do? So that's yeah, just yeah, that's fine. Yes. So Word files. Some of them see the changes that. That well. Word files. Word files are actually folders and other files in them.
但是我就是想把它
So we'll see the difference. Okay, but it's working.
去就在这上面。
Very email.
No, this process is mainly to do
那搞吧。
Yeah, exactly.
So,
Yeah, yeah,
so
yeah.
word
Yeah,
files are.
but
yeah. That's why I wasn't worth.
But we're gonna use something that makes it extract the grass and files. But why do you have to track line as well? Because it's not readable by a text. If that's
是的。
when I mean text that are a big word, I mean like the.
那不就跟
Yeah, I
我一样
know.
吗？有什么区别？
那不，那我
Yeah,
我不打了，我从这里直接输入。
So it's working.
都是
Yeah, I mean,
然后你同意了。
who is it? They're not here. Okay, we can deal with that in a sec. Okay, let's shuffle.
Hi, Henry.
Hey,
The desktop version have the same function with the website.
no,
Like it can only edit and upload instead of viewing other.
the desktop version is actually it's just it's purely for uploading and downloading. It won't have things like editing functionality and stuff like that. But we don't need to use that. We're going to be using Grasshopper to edit. Yeah. Those of you guys are here. What we're going to do, I'm going to move all of this stuff here. Do you want to try and rearrange these tables so you guys are all looking this way? Please? Yeah, cool. Jackets. Yeah. What I might do is I'll.
Yeah, what about?
Yeah. Yeah, you don't have a laptop?
Yeah, I never.
Yeah.
We're updating that way.
Wait, what's this?
Right on that one, laptop.
Yeah.
It's on the download.
Yeah, no, like the charger. What is this? Is it a 300-watt charger?
你听得到吗？
看不到，看不到，就是。
你看不到那东西。
Yeah.
我看不到，我看不到。
No, you're working back in
啊，你看不看？
我看了，
我看你在那怎么？
哪儿呀？
你他电脑里。也是他电脑上的地方。
Why is this even tied?
Huh?
Oh, wait, is it tied off anyway?
Jesus. It's been like this multiplied. Ah,
Don't we take all the charges off first?
no. It's definitely tangled.
use your
Huh?
not for this one. They're not for this one.
Is that's lower than before though, right?
Yeah, I think we've reached.
Yeah, 331.
Yes, but what we do is we're gonna put this apart. And I'll look this way. Then I might have another-
I go around.
This one?
Choose through window.
Uh,
Eats renders for breakfast.
huh?
Why would you use laptops for
That's it. Otherwise, I wouldn't just put in like
I'm sitting here. This is my desk. Unless you want me to be yelling at you.
Maybe we'll
might-
this sword.
I don't mind, but I will be yelling.
I mean, if you want to turn it. Yeah,
We're gonna try and split it up. Yeah? So that there's a row in between this one and this one.
Oh,
Yeah?
Yeah.
So people aren't doing this. Question is, where is my laptop gonna plug in? Yeah. Yeah. Good. Good. Oh, these are computers.
Yeah. Oh yeah, so they could connect, right?
They might be able to just connect. Do you want to
They're
try
looking
it?
at the link. Right?
Yeah.
How do you use it?
Huh? Yeah, it's touch screen. Yeah, let's just move it. Yeah, but I'm gonna be presenting this way, right? So, we have enough. What? Yeah, so. These up. Huh? So what I'm going to do is that can supplement those guys, right? Huh? Sorry, what? I think so. If we don't, we can just add more tables from here, right? Okay, I'm gonna take. Yeah, that way. These are. Oh. Yeah. Yes, that would help. That's- This string. Yeah. Yeah. Then yeah. Where's my power? That's fine. He might say something. There we go. Okay, now yeah, yeah. You want if you can see, yeah, go for it. Yeah, sorry about that. You can put tables in if you want.
You can make work, you make work. And you'll be started with it. Front row seat.
I've got an idea. One of those computers next to that, so they can see where they're right. Yeah. Why isn't this? Huh? You won't be able to see, but yeah. That. Sorry. So one of you two, could I send you a Zoom link? And then could you connect your laptop to that? And then put my Zoom link on there? Because you can see this. And what it does is it means that those guys can see that. Thank you very much. Might as well go with you. Are you on this list?
Yeah, I just think.
Huh? Which one is it? Sorry? VENG? This one? Cool. I'm gonna upload you the link via that. Cool. And you'll have to plug the HDMI in. Is there a HDMI there?
Added that, so that should be good.
There's no HDMI cable? Okay, I'll go find one in a sec. I'll just wait till it seems like everyone's back.
Put it down, it's easier. Yeah. Right? You know what, it might, yeah, brilliant.
Which day is he running? It's gonna be married, born, right? Yeah, Saturday, because I can't currently see. Yeah, that's why I thought, I'm trying to make it pretty easy, yeah. Thank you. Okay.
Hello. That's gonna help. This works better, right? Yeah, cool. Because you guys can't see that very well. Try and plug it. But unplug it. Up the shower. Oh, you connect them to a phone. Wow. That's fine. That works. Oh. I didn't. Yeah, I think it's been done. I could just try it. Okay, just try it. Oh, no. Maybe I'll plug it in. And then I'll put it into the phone and then wait. And then okay, cool. Right. But everyone was like, like when I said it, it was like, it was no like, well, that's one down. Okay. So okay, who hasn't used Reddit? Okay. Well, you're learning Reddit. The best way possible. Like, not. Okay, go. Is that enough space for everyone? We need one more desk. Can you try this computer? Can you try this computer? Yeah, that doesn't. Um. Okay, I've got a solution. Okay, I can't seem to get that thing to connect. One solution could be there is a screen over there that this group may or may not be using. Do you want to, I know. So do you mind just exploring that option, or maybe find a screen somewhere else that no one's using? No, just another one, because this one just doesn't seem to want to connect via HDMI. Maybe, yeah, just swap it. And then in the meantime, I'll give everyone the Zoom link. Okay, so those of you who are sitting far away, there is an option to get that screen to work. I've sent Danielle off to try and find another screen. That's one. The other is I'm going to put this link on my repository rather than this Veng repository. So you can go and look at my screen on your computer if you can't read what's up on the screen. Does that make sense? I swear you've been at Cox recently, haven't you? No, you have.
I would love to.
Okay. For a visit. Then where have I seen you?
People always say that to me. I think I just have a very good like.
You have that type of
regular
face?
face.
Yeah, a regular
Very
face.
similar.
You could be a spy. No, I'm sure it's somewhere. Here we go. So, if you go to GitHub, and you search for Cephbin, and I'll put the name back up large in a sec. So if you go to that address, this is only if you can't see, right?
From where do we search this?
So what? Hang on, I'll talk you through it. So once you get to that address, you should be able to. You'll get this. If you scroll down, you should see that the repository that I just made should be pretty much at the bottom of that page. If you go to that repository in the main page of that, there should be a link there that you can use to connect via Zoom. But Danielle is also trying to solve this now, and she might bother one of you to solve that. Next week, Danielle's laptop will be here and working, and we'll be using her laptop to do this. So thanks, Danny. You don't need to share your video or anything. Okay, so you guys want me to work in Rhino 7 for now? I'll work in Rhino 7. So, you guys haven't ever been expected to use Revit, but have you been expected to use Rhino? You're all using Rhino, so you're all familiar with. I don't need to teach you guys how to use Rhino. Is that what you're saying? Who thinks they need Rhino help? So you've never used Rhino? Okay, a little bit is enough. And you've never used Rhino? That's enough. A little bit's enough. Okay, cool. Like, would you prefer using Rhino over SketchUp? You prefer SketchUp. I'm gonna change you. You're my challenge for at least a few weeks. Okay. Okay. So Rhino is a command-based program. So all the little buttons and all the little options, all they do is they just pipe commands into the command line. We can also pipe our own commands in just by typing. Before we go much further, just letting you know you can type Grasshopper in to start Grasshopper off. But before we even open Grasshopper, I'm going to show you guys Package Manager. So if you type Package Manager into Rhino, I unfortunately cannot make the command line that much bigger at the moment. So Package Manager. Oh, look at myself. I don't want to be because of the recording. So how do I make this? Why does it come out this? Oh yeah, that's right. I reckon it's one of you picking my voice up and sending it through. It's you guys that have got to mute. Blah 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 blah. Okay. It's still doing it. Yeah, could you guys, anyone who's connected by Zoom, mute. What? Hello. Yash? Could you?
My volume is down.
It's not mute. I can hear you. It's mute now. Cool. Thank you. Wow, that picked me up quite well. I'm not well enough. Okay, cool. So Package Manager is where you can install all of the sort of extra add-ons that are available for Rhino and Grasshopper. There's a whole bunch of them in here that that you can find, like Lunchbox or TT Toolbox or whatever. It is how we install these. It is the main way to install the add-ons. Another way is via this website called Lunchbox. I'm not Lunchbox, sorry, Food for Rhino. The reason I say this is I'm using a plugin called Sunglasses. It's very similar to this plugin called Bifocals, and it is going to make my Grasshopper function a little bit differently to yours. If you want to make if you see anything that I'm using and you feel like it's not vanilla Grasshopper, you can probably get it via the package manager. Sunglasses does not come via the package manager, unfortunately. So you can jump onto this website, foodforrhino.com. Look for sunglasses and we can install it. Now, because you're installing this via Food for Rhino, there is a process that we have to go through. So you download this. It'll download a GHA file. You'll probably have to have an account. The account for Food for Rhino is free. You just need to make it. And I think this is the same for Mac, by the way. Yep. There's the GHA file in my downloads. In Rhino, if I type Grasshopper, that'll load Grasshopper up. And I can go File, Special Folders, Components folder. I'll leave that up. You can see it on Zoom. If you go to the Zoom link, you'll see me pointing at it right now. Files, Special Folders, Components folder. Is that working now? Okay. Thanks for grabbing that. And what you want to do is you want to paste the sunglasses.gha file into the folder that gets loaded up, which will be some combination of C, your username, app data, roaming, Grasshopper libraries, or who knows what the Mac version is going to say, but it's something like that.
The special folders where like
File,
yeah.
Special folders, components folder. Yeah. This is all just to get you guys in the same visual environment that I'm in. Now, the other thing that you will need to do is just right-click Sunglasses, that GHA file, go to Properties. It's possible that it will have this little thing here that says Unblock. I don't have it, but it might have it on yours. So right-click, and I'll repeat again, right-click, Properties, and then in this down here, you click Unblock. If you ever install a plugin for Grasshopper this way and it doesn't work, it's probably that. Go find that GHA file, right-click it, Properties, Unblock. It will not show up in Rhino or Grasshopper until you restart it. So shut your Rhino down and start again.
Most of us connect via VPN. I think that doesn't work. Do it through the
Oh, what?
yeah.
Oh, no. Show me.
Well, like when you want to access Rhino, you have to do all the business down here.
Yeah.
Connect to the Sydney network.
Yes.
And
You're
then
not
Rhino.
reloading. No, that'll work. It's installed on your computer. Yeah. It's
Yeah?
installed on your computer. It's just
Okay.
yeah. You're not on
Okay,
a
good,
remote
good.
computer. Yeah.
That's just the access.
The VPN stands for virtual private network. So by connecting on the VPN, you're basically putting your computer on the university network. And the university network then has a server that has the Rhino licenses. So you're putting your computer into the environment that has access to those Rhino licenses
Right.
to then get
But we
access.
have the program.
Yeah.
Just log in with writing on the email confirmation for Rhino.
Cool. Did you restart Rhino? You won't. What do you mean? What are you looking for?
Should I be looking for anything?
I'll show you where you can find it. Welcome back. Is that screen working now? Yeah. Sorry. That might help. I'm loud. I'm a loud person. Okay. What are you looking for? How do you know that sunglasses is installed? If you go to display, you will see sunglasses in the display list. Can you see it? Yep. So you've downloaded the file. In Grasshopper, you can go File, Special Folders, Components folder. That'll open up your Windows Explorer. That's where you paste your sunglasses file to. As a double check, you right-click that file, hit Properties, and just check that there's no unblock button. And if there is, you click the unblock button. Did you get it?
That's the wrong thing.
No worries. It should be here.
Like that.
Can I see? Oh, what? Yeah. Oh, that's why? Why does everything have to be so different? Where's yours?
Oh, yeah, I have it. Oh my god, it's just I was on the wrong tab. It was
Yeah?
that one, it's that one. Yeah, okay, got it.
And then have you got sunglasses in there? Cool. Because yours is not installed. Okay, you know how to do it. Yep. Okay, the reason I've done this is when I
Mine is in
Well,
go
someone
out
is
of Rhino
thinking
and then restart Rhino. Yeah, I'm restarting my Rhino.
when I grab a component, the component will, if I don't have sunglasses on, it won't put the name of the component above. Okay, and your Grasshopper might look a little bit different to mine right now anyway, right? It's actually gonna probably look like this. Yeah? Like if I go and grab these components, this is what your Grasshopper looks like, yeah? Can I just confirm, no one here's had any experience with Grasshopper, or if they have, it's been minimal? Minimum? Okay, we're gonna work with icons, okay? Because I'm a visual person, and I really hope as architecture students, you're all visual people too. So we're gonna turn on under display, draw icons, right? That means we are now working with a pictographic script, which might be really hard for some people who are beginners like you guys. So that's why I've got you to install sunglasses, because when I turn sunglasses on, it then puts the names of the components above. Yeah. And I can also, in the sunglasses, there's an option to change it to, rather than displaying nicknames, if you turn that off, then it'll give the full name. So that's what I'm going to do for you guys, so you can read it. You don't have to set it up the same as me, but if you do, then that's what I'm doing to make it work that way. Cool. So here we can see that's mass addition, this is factorial, that's remap numbers, and hopefully you can then put the function with the icon by using sunglasses. Does that work for you guys? Did you learn which way, like with the grasshopper that you've used, which have you used it with text or with icons? Good. There was a hand at the back.
Can you go back to making not the nickname, the
Yep.
full name?
Yep. Could someone around there mute? Can Min mute, please? Min?
Yeah.
Thank you. Thank you very much, Min. Where are we? Okay, so once you've installed sunglasses and restarted Rhino, started Grasshopper up, you'll find sunglasses here. It's probably best to go grab a component or two and just chuck them in, because you'll then see the little name appear on the top. The way this works is if you click on this, it'll turn it off and on, off and on. And then on the right, there's a bunch of options, and one of them is the nicknames. So you can set that to display nicknames or display full names. Yes, Min. So that means it's not installed. Okay, could you share your screen? I think we're going to use Zoom. I like Zoom because I can just do this. I'll just get her to share. Min, are you okay with everyone seeing your screen? It's dying.
So much, so many tabs, so many apps.
Oh, okay. Okay. Yep. Okay, cool. Have you restarted Rhino? Can we just restart it again?
What's the difference between draw for names and sunglasses?
I'll show you. May I more? Doesn't look like I can remote control this computer. Okay, I'll come over and remote. Is anyone else having issues? No. Okay, good. What did I say I was going to teach today? Are you guys doing it through bifocals? Are you using sunglasses or bifocals? Okay. I heard you say bifocals. Okay.
For kids, you might use
Okay, so we've technically done Rhino because you guys all know how to use Rhino. Grasshopper. Doing Grasshopper. Okay, so if you guys want to use draw icons, you know where to find that. Now, someone asked me what's the difference between draw full names and not? The difference is these components have these little inputs, and it shows you like a really mini version of that input. In this case, for bounds, it would show N and D. If you're getting used to this, you can draw it with a full name, right? I prefer it without because it makes the script like a more organized. There are also some things that break when you use draw full names. So just consider that. But if you're having an issue with a particular component, and you sort of we're getting up to the point where I have to explain this anyway. But the anatomy of a component is that it runs left to right, and these elements you can mouse over them, and they will tell you information about that particular input or output. Okay, so mousing over N tells me it's numbers as a list. It's got a description, numbers to include in bounds, right? So there are these. If I go get a slightly more advanced component, like Voronoi, if I mouse over, I'm not sure what this one is. Boundary, optional containment boundary for diagram, right? So that's really that's the difference between drawing full names and not. Cool. So is everyone's good for me to start with Grasshopper? We're going to write our first ever Grasshopper script very quickly, and then we're going to jump to being even more advanced. Okay. So I guess the question is, because this can change my approach to teaching. Do you guys use Revit to deliver your designs? So I don't need to show you guys how to connect Rhino and Grasshopper to Revit because you guys don't really use it, right? Yeah. Okay. Good. Okay. Because I was going to show you guys this thing. So there's this thing that you can install that lets Rhino and Grasshopper run inside Revit, and you can then control your Revit model with Grasshopper. But you guys don't use Revit, so it doesn't matter. Huh? Yeah, I can show you. Yep. Okay, so do you want to do that? We'll do that today as well. I'll get you started. And then just remember, if you want to play around with Revit in this studio and you want the safety net of being able to play around with Revit and fail at it, but still, have a bit of leeway for a mark, now's the time to do it. Okay? Because I'll take all that work that might look shit and I'll still mark it. Okay? Cool. Okay. So before we do that, we'll just talk about Grasshopper for a bit. Grasshopper is it's a different environment to Rhino. It's kind of like the dream space of Rhino, right? I'm going to use two analogies for this in a second. This one is the dream, and the other is it's like baking a cake. Okay. So the reason why it's a dream is that the stuff that exists in Grasshopper does not interact with Rhino unless you explicitly tell it to. So if I draw a sphere, and I'll just quickly put a sphere in Rhino, I should be able to see that sphere. Hang on, just go to teaching mode. There we go. I can see that sphere. It is not selectable. It doesn't have a layer. If I print, it's going to print out as red. If I select it, it's going to turn green. There's no way for me to control it inside Rhino, right? So these two things are explicitly disconnected unless you tell them to connect. Okay? Huh?
So cool.
So what's cool? What are you doing?
Just put a spear in. Spear's so cool.
I saw a spear. So yeah, just so you know, you can draw spheres in Rhino as well. But
It was like glowing.
boo, it's not glowing green or red. Okay, so Grasshopper, it would be completely useless to just to use Grasshopper if it had no way of connecting to Rhino. So the means of connecting it are via these things called parameters, and you can find parameters in this tab, in this ribbon. My ribbon's going to look way more crammed than yours. Yours is probably going to come up to about here. It'll probably say transform or TRNS and then display, and then it probably has this thing says Kangaroo 2. Yeah. And then all these other things are plugins that I've installed. Okay. So if you're working on vanilla Grasshopper, you're not going to see any of those. And then in the param section, you're going to find a bunch of geometry parameters and a bunch of primitive parameters. There's various other inputs and utilities, but this is how you connect to the model. So these have different object types, and we've got here the point object. So I can put that into the canvas, and the way that I connect that point, so that is an empty point. You can see it showing up as orange. Orange by default is empty. If I right click that, there will be some options to connect that to the geometry in the Rhino environment. So there's either set one point or set multiple. So by setting one, Grasshopper will disappear. It'll give me an option to pick a point. I don't actually have any points in Rhino. So hang on, before I do that, I'll pick a point. I'll draw a point, right click, set one point, pick that point, and now that point, that little cross there, is Grasshopper's way of representing a point, right? If I click on that component, it's containing that point. It'll be green. If I deselect it, it'll not be selected and it'll be red. Cool? That point, if I move it in Rhino, it's still there in Rhino. If I move it, it is now being moved in Grasshopper because there's a reference connection between them. So now if I connect, see with my sphere, it wants a base. If I put my sphere at the base of that point, if I connect them, when I move that point in Rhino, this point is taking the reference and rerunning the whole script from that position in the script. Because the point's moved, the whole script's changed. It'll recompute that, and it will re-render that sphere at that new point. Cool? Does that make sense? So that happens with any geometry or element that could exist in Rhino. If I draw some curves, I can grab a curve component, right click it, set one curve, and that will pick that particular curve. Cool? So this is kind of the magic, the initial magic of Grasshopper is if I pick a component, like extrude, and I run that. You don't need to follow this, by the way. This is just a little quick demonstration. but that extrude versus extruding in Rhino, by default, if I move that curve or make any edits to that curve, that extrusion doesn't change, right? But within that dream space of Grasshopper, why can't I select anything? It's frozen. Is my internet's disconnected? No. Where's my phone? Is my phone over there? No, it's still running, but let's just make the connection strong. Your point didn't work.
And my grasshopper's not disappearing to me.
Okay, so that's different in Mac, but it should. You can just minimize it and then pick the point.
Do I just click on the point? Or should there be a pop-up that says it?
Just follow through this. So right click, set one point. Then in Rhino, the command will say point object to reference as in the command line. And then you can pick the point. Yes. What? Oh, that's this guy. Did you yeah, you got it.
Oh.
Could you oh, and then grab that. And then drag it up. Thank you very much. You got that up? Good? Cool. Oh, that was stressful. The first Grasshopper script. We've got through it. Okay, so you guys should have a point that you've got a point that you can move. Everyone's pretty much got a point they can move in their sphere moves. Yeah? Cool. So if I get back to my point, the cool thing about this is I move that curve, that extrusion doesn't move, right? It has no relationship to the original curve. But if I move this curve, the extrusion moves, right? The process that I want to impact, put onto that line by extruding it has been remembered. It's been mapped in Grasshopper. And so I can even edit that line and it'll change, right? So that's the initial magic of this, right? But what use is this to us if it's not in Rhino? Yeah. So now if we just move out of the dream space a little bit into the cake baking space, everyone here bakes cakes, right? Everyone has at least cooked something. They've made an omelet, which is just a savory cake. They've made, right? You've put some liquid together for making food and then you've cooked that, right? At what point can you go back and change the recipe? Huh? At the liquid stage, right? Yeah. So if I've got 2 eggs and some chocolate and a bit of flour in that, and you've got that goopy mix, I can add more eggs. I can change the mix of that. I can change it around before it gets put in the oven. It's the instant it gets put in the oven and that gets cooked or baked, right? That the things become static and we can't change them. They lose their versatility, right? Before I bake it, I can choose which tin I want to pour the liquid into. I can get a round tin, I can get a square tin, I can get a duck-shaped tin, whatever, right? So the function for taking an object from Grasshopper and putting it back into Rhino is called baking. For some reason, the symbol for it is an egg. I think it should be a cake, but it's an egg. And you can find that in the I forget what this is called. The little function wheel. You can get that by hitting control space. And it's this little egg. You can see there it says bake. Fried egg is bake. I know, but I know, but yeah, it's an egg. You hit the egg. Oh, that was for the sphere, and you can see there that sphere is baked in, right? See how that's now selectable? The thing is, that has no relationship with the Grasshopper script anymore, right? So I've got a cake mix, which is Grasshopper, and the cakes that are it's baking, which is going into Rhino, and those objects are now static. If I change the radius of this guy, oops, that's huge. Hang on. If I change the radius of this, it does not change the radius of the baked object. Okay. So there, that is just the mindset that you've got to get into as you're starting to work with this. Does that all make sense? Yeah, cool. Everyone good? Baking, referencing, cool. There was another option for referencing. There was reference 1, and then there was reference multiple, right? I've got 3 curves here. If I reference set multiple, Grasshopper lets me select multiple objects to put into its function, and then it does the process to those objects multiply, right? So that I've brought in those 3 curves, and we're now extruding all those 3 curves in the same way. Okay. The way to have a look at that list that you've actually brought in is via this fantastic component here called the panel. It's this little post-it note here in the inputs. The panel has 2 functions. It allows you to double click it and type stuff in, but it also allows you to plug elements into it and read what's in there. So this is telling me there are 3 components, 3 geometry elements in that list. There's a referenced line, a referenced curve, and another referenced curve. Okay? 3 curves. If I have a look at what's coming out of the extrude, I'm getting 3 untrimmed surfaces. Cool. So this is your way of looking at what's going on in Grasshopper. There are other ways of doing it, but this is the main reason, the main way. And if you look at my scripts, there's going to be these all over the place because I don't delete them. I kind of want to watch things. Okay. So Grasshopper's power begins to evolve once you start to once you start doing multiple things to multiple objects. And so you can extrude, we're extruding these curves by all 3 of them via 1 component, but there are other components that rely on multiple objects relating to each other, such as things like lofting or like Voronoi processes. So if I jump over to surface, I can find this component here called loft. And with these 3 curve components, I can plug them into that, and we can start playing around with the more complex geometries that exist in Grasshopper. So hang on, I'll just do this. So you can see what's happening here is this component extrude is just taking 3 curves and extruding each of them the same way. While this component loft is taking 3 curves and lofting between them, right? So some components work where it looks at all of the elements as a group and works on them as a relationship between them, like loft, while others will just work on them individually and extrude them, or whatever, right? Is that am I losing people or are we good? We good there? Does that make sense? Okay. There are hundreds of components in Grasshopper. Without installing plugins, there's hundreds of them, right? We're not going to go through each one. There's no point to go through each one, but they are organized in a nice way. My Grasshopper screen probably looks a little bit different to yours. Even when I'm on like the parameters page, it probably looks different. What I've done is I've got this thing called obscure components turned on, which what it does is it tries to fill the ribbon with as many components as possible that you have in that particular environment. So that's going to show you at least all these little icons rather than having to dig deep into these panels to find them. And what you'll find is that Grasshopper is organized in a way that deals with its function. So if I am working on some like curve-based function, like let's say I want to divide a curve up, where do you think I'm going to find the component that might do that? Even though you don't know it, where do you think it might be? Where? Yeah, under curve, right? It's probably under curve. And then in curve, all of these components are divided up into their subfunctions. So we've got analysis, division, primitive, which usually means like creation, spline, which is very much referring to curved lines. Am I bothering you? Am I too loud? Okay, cool. And then utilities, right? So even though you don't know these components, you probably will be able to find your way around. What I find is when people are teaching Grasshopper, they start showing people, you double click and you type in the component, like mass addition, right? The problem with that is, for me, is that I feel like all you learn are the components that I teach you, right? So what I want you to do is I want you to get familiar with Grasshopper via the ribbon, via these sections. And I'm going to talk you through each one. So parameters, I think we've kind of covered that. That is dealing with the raw building blocks of how Grasshopper works. So you've got geometry, which is every geometric object type that could exist in Grasshopper. Primitives, which is anything else other than that. So things like colors, numbers, domains, etc. Your inputs and utilities. So input, you can find things like an MD slider, which is just like a funny little component that lets you drag a slider around and you'll get a point output, like an XY coordinate as an output. The first one I should have started with is a number slider, which is like the bread and butter component of Grasshopper. And we'll talk about that in a moment. We'll write another little script in a minute using number sliders. Cool. Utilities, you're probably not going to deal with them for a while, but there are some utility functions in there. And then Spiderweb, that for some reason Spiderweb puts its components in my parameters thing, so we can ignore that. I have some plugins that will show up in here. So this little guy here is a plugin, and this little guy is a plugin, and that's probably also a plugin. So your parameters page will look a little bit different to mine, but that's parameters. Math. What do you think math is? Yeah, pretty much anything mathematical, right? So it's going to have your domains, and we'll deal with domains next week. It's going to have stuff with matrices. We're not touching matrices at all, so it's cool. I'll mention them, but not the way Grasshopper deals with them. Operators like addition, subtraction, multiplication, Like if you have a number and you need it to be 5 times larger, you're going to find it in math, right? Cool. Set. This is the workhorse of Grasshopper, and it's where we're going to go once Grasshopper starts to get more advanced. Okay. This is how set is really about how you manage data in Grasshopper. And it's like if I need to make a truss or a stair and there's patterns, that's probably where set's going to be. Okay. Vector is just a fancy way of saying point. Okay. So you're going to find all the points, planes, and vectors in here. There's means of creating grids, which are basically just different arrangements of points. And there's fields. We won't ever touch fields. But I know some like scientists use Grasshopper and they could use fields and they're useful for that, but we don't need to play around with that. Self-explanatory: curve, surface, and mesh. You guys know the difference between all of those three things. I'll talk about meshes a little bit later. Meshes are very different to surfaces in Rhino, and I'm not sure. Like, did you guys get taught like how NURBS works? I've got some people saying no, and some people like. Do you know what NURBS stands for? Okay, if I said degree 3 curve, who could you please put your hand up if that doesn't make any sense to you? Degree 3 curve. Okay, and then those of you who do know that makes sense, do you know the difference between a degree 3 and a degree 4 curve is? No. Not yes, but no. No. So no one knows. No, no, no. So who thinks they know? Okay, cool. I'll teach you guys that one day. It's not the number of control points, because look, just to prove that, you are right. It's the number of minimum control points, right? This is a degree 3 curve. It can be made with three points. Okay. But you can make a 3-degree curve with 4 points, right? But you cannot make a 4-degree curve, oops, unless you have 4 points. Okay, so if I try and make that with 3, that's probably, hang on, that's probably forced it to be degree 3. Curve degree. We're getting distracted. Oh, that's a 2-degree curve, actually. But yeah, we'll get into it. I think it's 5. You need 5 points for a 4th-degree curve, and you need at least 4 points for a 3-degree curve, and so on and so forth. If you think about it, how many points do you need for a 1-degree curve? Right. So it's always that degree plus 1. We'll get into that later. Much, much later. Maybe as a request, hey Andrew, can you explain that? It's useful, and you'll see why. Okay, so you guys don't understand NURBS. Based from my perspective, you don't understand them. So I will explain them later. Okay, but you can find NURBS surfaces in Surface, mesh surfaces in Mesh. If you want to take two things and combine them together, like clash them, be that a curve versus a surface or two surfaces, you're going to find that in the intersection thing. Like if you want to trim something or you want to boolean something. Am I saying things that make sense? You guys know boolean, right? Yeah, you're going to find that in intersect. If you want to move it, something, transform, like rotate it, orient it, squash it, you'll probably find that in transform. And if you want to look at something, you want to play around with how something looks, or you want something to show up on the screen, you'll find that in display. I'm not going to mention kangaroo. like, for a long time, not until the second half. But Kangaroo, it's there. It'll be Kangaroo 2 with like a little, that's a physics engine. Okay. So you can use that to create a physics simulation, like let's say a cable roof. You can set up the cables in the roof and you can pull them taut and actually get Grasshopper to simulate that and then come up with a final geometry. So we will actually play around with that in the second half of the semester. Cool. Okay. Shall we write one more little Grasshopper script? What should we do? Should we start with the stair? We'll start with a stair. So you guys have to design a stair, okay? Stairs are fantastic, beautiful things, I think. They give us so much opportunity to do something cool. There's no way we're going to design one right now, okay? But we're going to try start. For a stair to work in Grasshopper, we're going to have to learn more advanced things than what we're going to get through today. So what are we going to do? Okay. How about this? This will be something useful for everyone, even if they're never going to use Grasshopper again unless they use it for this simple process. Let's make a tree maker for plans. Okay? Cool. What we'll do is we're going to grab a bunch of points in Grasshopper. So, I mean, in Rhino. So in Rhino, go draw some points. This is where your trees are going to be. You don't want to draw points. You don't want to draw points. You finished drawing points. Okay. $12:30. We got plenty of time. We could probably do next week's. We could start next week's lesson. Okay, we'll do this one first, and then we'll do next week's. I'm trying to get you guys confidence up with this, okay? Because I know all of you are quite, like, it's quite scary opening Grasshopper up, right? Some of you have tried it before and gone, what the hell is this, right? Yeah? Yeah. No, you haven't even done that? Oh, okay. No, okay. A little bit, okay. Yeah, I think, okay, we're going slow. We'll go slow. So we're going to grab a bunch of points. So what we want to do is grab the point component from, actually, before I do that, I've got to stop myself. So we're going to make a tree maker, right? Let's not even think about Grasshopper for a second. Come over here to the red board. Do you mind unmuting? That's going to help. Unmute. Yeah, so now it's going to record. Now I'm here, it's going to record. Unfortunately, there's going to be an echo, but whatever. Okay. So the tree that we're going to make is going to look like that. Right? Like, it looks like a planned tree, right? You know those little illustrative trees that do this? We're going to make this, okay? So we're going to talk through how do we do it? So, step one. What do I do?
Point.
Got a point. Okay. Now, you two know more input. What do I have to draw now? Next step. Circle? Oh, that is going to be a bit distracting. Now what? Now, by the way, we're drawing a circle using the point as a center point, right? But what was it? The branch. But what does that mean? We're gonna draw a line. Okay, I'll draw a line. Pardon? Between 2 points. Okay. From the center.
I mean, you give that point as an input for the,
Yeah, I'm about to draw a line.
and you find a point on the curve, and then you join the.
Yeah, okay, where do I put it? Tell me.
On the curve.
Oh, but where?
Wherever you like.
Wherever I like.
Okay.
One point on the curve.
Cool.
Okay.
And now I draw the line. Right? Do you see where I'm getting at? I'm being purposefully painful, right? Now what? Remember what it needs to look like. What's the next step? Huh? Draw another point. Okay. Cool.
Can you just rotate the first one?
We could. Yeah, that's one. So one thing you could do is you could take this line and rotate it using this point as the axis of the rotation. That is correct. You can do that, right? But we could also, rather than drawing a line between one point and another, and rather than drawing a line between one point and then drawing a line between one point and another point, we could draw a line between 2 points, right? So that could have been one step of the process. Cool? Does that make sense? Okay. What else do I have to do? Huh? There's another circle. Draw another circle. But now we've got that. Do we want that? Yeah, cool. You trim these lines. Okay, guess what? That process is what we're going to script, right? There is one slight thing that I did jump over because it is getting advanced. And that is when you said, what did you say? What was your input? Huh? No, your input was put point wherever you want,
Okay, yeah.
right? You can't ask a computer to do wherever you want because the computer doesn't know what that means, okay?
I put the point wherever I want.
But how, okay, so how do you, where is that point?
I don't know.
So let me continue on here. How many points have we drawn? How many points are we going to put in? Are we going to put 1 tree in? Or are we going to put in 10? 10, right? Or at least n plus 1, right? An indistinct number of trees, right? So if it's where you choose, you're going to have to choose each tree, right? What don't we want to do? We don't want to do that individually, right? If we said, okay, we're going to pick this point, and we don't say, we're not specific about it, the computer's just going to do this. It's just going to draw a bunch of the same tree over and over and over again. And that doesn't look right, right? Because we're used to sort of seeing trees that do this in plans, yeah? Oh, that's not. Right? So at this point, we're going to have to somehow decide, hey, computer, put it somewhere, but put it somewhere random, okay? So we'll do that. We'll get it to put it somewhere random. So technically breaking the generative design rules of the university. We've made trees that are now plagiarism. Well, not plagiarism, but like we didn't choose where those branches were, the computer did. Does that make sense? Well, you can mute me now. You can mute me. So that was a process of pseudocode. It's very basic pseudocode, very basic. Technically I should have mapped it out rather than just drawing it, but drawing is pseudocode, right? You can already pseudocode. Yeah? If you know what I'm getting at. Yeah, cool. You look stressed. Yeah, good, good. So, what did we do first? Pick the points. So we've drawn points. Let's pick them. Set multiple points. You can. You guys are going to code this for me. I'm not going to do anything. What's the next thing? What's the next step? Circle. Okay. Where do you think we can find circle? A circle is what type of geometry? If you look at the ribbon, what type of geometry is it? It's a curve. Yes, you're right. And there are 1,000 different ways to draw circles. In this case, we're going to just use circle CNR. Or yeah, we can use circle CNR. CNR stands for center, normal, radius. So I'll explain normal a different day, but it doesn't mean the opposite of weird. Um, but you might actually be able to work it out. Now, radius. How do we control that? With a number, right? Yeah, so there are different ways of putting in numbers. I can measure a curve. Like I can grab this curve here and and measure it, and then use that as the radius of my circle. You know, I've got the length of that curve, and that's changing the circle radius. It's probably not the right way to do this particular thing, but there are hundreds and thousands of ways of getting a number. Okay. But the bread and butter way of doing it in Grasshopper, when you're the one defining that number, is via the number slider. Okay. The number slider has a minimum and maximum range. By default, it's 0 to 1. You can always double click the left-hand side of the number slider, and it will bring up this dialog where you can edit and change the minimum and the maximum. And that will then also have a range so that if you change one of these, if I change that to 10, you can see the range is now 10. And if I change the minimum to 2, the range is 8. So if you change any of those things, one of the other two will change. You can also set the value of the slider here, and you can control with these 4 options, a floating point number. Floating number in computer science and maths is referring to a number with decimal points. You can have a natural number or an integer. That's something without decimal points. Or you can have an integer that is even or an integer that is odd. In this case, let's just go for a float. Okay. Now, so you can see here, I can pull that up, and that's 10 is nothing for what I'm working with. So let's make that 40. So I can play with that slider, and I get my little circles to change their radius there. Cool. Quick tip. If you want to speed code in Grasshopper, you can double click and type a number into the text 9, and it'll make a number slider between the 0 and the closest rounded 10 to that number that you've typed in. If you want that number to be a float, you can type 9.0 as long as it's got a decimal point, and it will now be a float. If you want to do a number between two numbers really quickly, you can type 40 is less than 100, and it will create a number slider between those two numbers that you've typed in. Okay, cool. I'm sure there's other little tidbits in there, but those are I never use them, but I see other people use them, and if you want to use them, now you know. Cool. What was our next point? Our next step? Actually, let's just do this to 1, by the way. Boop. For now, I'll show you with 1, but we'll do multiple in a minute. So what was the next step? Choose a point. Okay, where do you think that would be? Pardon? Yeah, so we're choosing a point on a curve. So where do you think we're going to find that function? Picking a point on a curve. It's either going to be in vector, right? Because we're doing a point, or it's either going to be in where? No. What are we doing? We're analyzing a curve. So where are we going to find the component? Curve, right? Now, if I just pull this up, which section do we think we're going to find this? We're going to find a point on a curve. Are we dividing the curve? Are we analyzing the curve? Are we creating a curve? Or are we doing a curve utility? We're probably doing analysis, right? And if we open that up, this is where I'm going to tell you which one it is. But there are a few in here. So you can see down here, where is it? There is a function called point on curve. I think. Where is it? There, this one. I hate this one. Don't use this one. Okay? This one's crap. This should remove this from your vocabulary completely. And I'll explain why. I'll leave it there, but the actual mathematical term that people use to find a point on a curve. Everyone here kind of did maths in high school, right? When you try and find a point on a mathematical function, the terminology for that is to evaluate the function. So if we evaluate the curve, we can get the point on the curve. So here it's evaluate, where is it? Evaluate curve there. Now, the reason why this component is 1,000 times, infinitely times better than this one is that the point on the curve that you are evaluating is controllable by the script, whilst this one, the point on the curve, is manually controlled by you. So here, see that 0.5? As I move this up and down, I can only have that set by me manually moving this up and down. Well, this component here, I can control that via any input as long as that input is producing a number. Okay, yeah, you can see here. Whoop, see how it's moving? Cool. So, I've got a number slider that goes from 0 to 1, but it's not making that much of a change on my point. There is a means to make Grasshopper think of things as percentages, and it is called reparameterize. If you have a curve or a surface and you want to evaluate that curve or surface via percentage, via 0 to 100 or 0 to 1, you can right click that input. So in this case, I'm right clicking this C value for the curve and hit reparameterize. And now my number slider that goes from 0 to 1 is going to go from 0% of that circle to 100% of that circle. Does that make sense? Oop. Is this sharing? Oh no, it's not sharing. I'm so sorry, people watching this in the future. I hope it's sharing. It's still recording. Okay, yeah, it's still recording. Cool. Pardon? It was sharing. Okay, yeah, you guys, actually, that's really good because you guys would have told me. Yep. Cool. Does that make sense? Okay. I'm gonna do something that fails. Okay? You ready? Ready to make this fail? What did we say we were doing before? We're drawing a line between 2 points, right? Or are we drawing two lines between a point and 2 points? Two lines, right? So we need another point, right? We could copy this and just create another point, right? Or why don't we just get this component to produce 2 points, right? So you could copy the number slider and plug two number sliders into this evaluate curve, right? How do you do that? You have to hold shift. Yes. So yeah, if I try and drag that in, if I don't, it's always going to overwrite the previous input unless you hold shift while you're doing it. You'll see there's a little plus icon that'll come up on your dragged arrow. And now that we've got two wires plugging into one component, one input, and see it's now producing 2 points on that curve. One which is connected to the first slider and the other which is connected to the other. Cool? Okay. This is purely, I know this isn't the most exciting thing in the world, but it's purely trying to give you guys like step by step the how to interact with Grasshopper, right? Cool. Have two different numbers. It's producing two now. Have you got, does it look exactly like mine? Oh yeah, it will be. Yeah. So guys, just to demonstrate, if I do multiple circles at once, it will only produce one point per circle. Okay, and this is what I meant by it's going to fail a little bit. Look, one of those sliders is controlling one circle, whilst the other slider is controlling the others. Yeah. So let's just to solve this, just so that I don't have to explain intermediate Grasshopper to you immediately, let's just do one circle for now. So go set 1 point and just pick 1 point. So right click, set 1 point, and then pick 1 point. And we've just seen the next reason why Grasshopper is so cool is you can just change the input and the script just runs on that input. Is it, have you got a question? Are the two number sliders different numbers? And you've only got 1 point? Yeah. So if you double click the name of the number slider, it'll bring up the dialog for the number slider. The options are the minimum and maximum, which is 0 and 1 as default. The range is just telling you the difference between those two. So if I change the range to 5, it'll change. See, it's going from 0 to 5 now. If I change this to 1, and then I set the range to 5, it's going to go from 1 to 6. Oh, that you're talking about the reparameterize? Okay. I right click the input for the curve and I set it to reparameterize. Okay, so a NURBS curve is made of control points. And the control points have a parameter based, they have a number associated with that. And in this case, this circle is using its circumference as its parameter. So it's using its length. So it's it's 80 times pi long. So when I set it to 1 along that curve, it's only going to be one millimeter along that curve. By reparameterizing, what we're doing is we're taking those control points and we're saying the start control point is 0 and the end control point is 1 or 100%, right? And then anything in between is whatever it is in between. So when you go to evaluate it, it's looking for the number between 0 and 1 rather than the length. Okay. Cool. Now, we're not making this the right way, and it's on purpose, okay? So if you think I'm doing it wrong, it's for a reason. Especially if you're watching this in the recording, it's for a reason. Cool. Now, we want to draw a line. Where do you think we're going to find lines? What type of geometry is a line? A curve, yeah. In curve, you'll find under the primitives, there's a whole bunch of options to draw a line. This guy here, line, creates a line between 2 points, right? It takes an A input and a B input. So we can grab our initial point and our new points, and we can draw a line between that and them. And that should all be interconnected. So you should be able to change your sliders and your lines should be able to change. Pardon? Yeah, why would you want to do it manually? Especially if you have 1,000 trees to draw, right? We're going to make this even cooler. Okay. Okay. What was the next step? We got to draw a circle. Guess what? We can just copy and paste. Now, what happens when did you guys see what happened when I copied and paste? If I copy and paste this circle, what else has happened? What secondary thing has happened? It's retained the input, right? So at the moment, I've got 2 circles that's using the same number slider as an input, right? So we're not going to see any difference. So just remember that if you want to copy something and you don't want it to retain those inputs, then actually what we'll do is we'll do that separately. So I can copy that number slider now, plug that in, and that replaces it. So that's overriding that. It's overriding the input. But let's say I actually want it to take this input. You can double click on a wire, and it will create this thing called a relay, so that you can use that to connect that. If you have a script that, like mine, you might have a script that looks like this, right? You've got some component that's really far away from everything else, or you have a complete mess. Hang on, here, I'll show you a complete mess. It's Rhino 7, but whatever. Cool. Yeah, you can have somewhat of a mess and you don't know kind of where this is going. And so you can double click that so you can at least move that to another input, right? So there's that. But there's also, if you find that you need to start bundling inputs together, or at least swap an input from one thing to another, or swap an output, you can hold Control Shift, pick a wire, either the beginning or end of the wire, and drag it into another input. So here I can move this output from this component to this one by holding Control Shift. Okay. If you've got a whole bunch of wires in something and you want to get rid of them, let's say, you want to remove the wires. So for example, if I did this, I've got 2 wires plugged into that circle You can right click it, and there is a disconnect function, and you can pick which wire you want to disconnect via this option, or you can select disconnect all and it will just remove all the wires. Okay, so right click, disconnect, and you can pick which wire you want to get rid of. And off you go. Cool. If you are lost in a script, like, hey, what is this? What is this connected to? Like this, see this relay? Where is that coming from? It's like miles away. There's another shortcut which is control. While holding control, if you hit one of the little arrows, the left and right arrows, the left arrow will go upstream. It'll take you to the components that are upstream of the component that's currently selected. And vice versa, if you click right, it'll take you downstream. And if you hold shift, it will select and concatenate into that selection everything that you have upstream. So these lines are being controlled by that script, right? The other components are not affecting those lines. Does that make sense? And vice versa. See this number slider? If I change this number slider, these components are going to change. By holding Control Shift and then pressing right multiple times or left multiple times, it'll take me upstream or downstream. Cool. And then there is also Control Shift A, which will select everything that's connected to that particular. It'll go both directions. Cool. Okay. What were we doing? This was just so that we could draw a small circle, right? Hang on. There we go. Small circle. Now, someone suggested that we trim. We could. It's a complicated function, but we can do it. But we'll try two methods. We'll do the trim. So where do you think we'll find trim? If we had to trim these lines with this circle, where do you think we'll find that? Intersect, correct. And then within that, there's a few ways that we can do it, but the fastest way is using this thing called region. In region, you can find trim with region. So you either have split with brep, which is brep is a Grasshopper's way of saying polysurface, trim with breps, which we don't have a polysurface, or trim with region. So region is a 2D enclosed curve. So we'll trim with region. The region, so if we mouse over this, the curve, C is the curve to trim, R is the region to trim against, and P is the plane. So in this case, we don't have to worry about the plane. So we want to trim these lines with this circle. And the output that we get is we want the curve. We can either get the inside curves as a list or the outside curves as a list. And in this case, we want the outside curves. Okay. But we still have this tree that isn't being trimmed, right? Exactly. Trim with region. Yeah, it's fine. We've only got one region. So that didn't trim the curve. Why? And I know you know why, but other people, why? Yeah, exactly. I can see all the other geometry that I've drawn previously. I can still see it, right? So there are some curves here, the ones that are trimmed, but they're on top of the curve that got trimmed, right? So we have to hide the stuff that we don't want to see. So you can select components in Grasshopper, and using that little context menu, which is Control Space, there is a dude without a blindfold and a dude with a blindfold. The blindfold is going to hide things, and the dude without a blindfold is gonna show them. Okay, so what I've effectively done is hidden the evaluate curve, which is going to show us the points. I've hidden the lines that I drew, the original ones, and I've also hidden the trim because the trim is going to be previewing both the outside and the inside. So I've hidden that, and now all I've got is that tree. Cool. Okay. Now let's go a little bit advanced. Okay. And I'm not going to explain exactly how this is working, but if I go and select multiple points, we are not going to get the same tree that we got before, that we're getting before. Okay. And the reason is something that I'll explain maybe next week or the next week after. But to solve this problem, we are going to use this component called graft. Okay. Graft is going to take our data and start splitting it into different groups so that it is managed separately. And the only reason I want to show you this is so that we can play around with another component just to make these trees look different. Okay, I just want to show you guys how to do random stuff in Grasshopper. So what we're going to do is we're going to take our point, we're going to run it through the graph. And actually, before I do that, I'm going to use that little shortcut that I showed you guys before. So what I want to do is I want to move these cables out of the point into the graph, right? So I'm holding Control Shift and I'm pulling them out, and I'm inserting this graph tree function into the process by doing that, we should now see that tree that we've drawn repeat across all of those. Is that what everyone's getting? So I'll do it again. It was surgical and fast. Okay, I dropped the graph tree in. You've got your original points. We're going to hold Control Shift, pull the outputs out of the point, and then plug the point into the input of the graph. Cool. Try that. You should get this. You can find graph in set under tree. Another nice little tip, if you have a component in your script and you're not sure where it came from, if you hold Control Shift and then click on that component, Grasshopper will show you where it is in the ribbon. Pardon? Control Alt and then click on the component. What have you got? Not working?
Missing something from trim, it's orange.
Huh? So in trim, I'm using the lines as the input curve and then the small circle as the region. The circle, so just remove the input for P. You don't need that. Yep. And then you're using the lines as the region, so you want to plug your circle into the R. That's it. Again. You can see how I can see into your brain if you give me a Grasshopper script, because I'm seeing into how you think about a problem. Like how do you draw this? You mentioned rotating. So by doing that, you document rotate in this, and then I can see that, right? Yeah.
What's the difference between graph and this and this and all that? So, say graph.
Pardon?
So if you right click on the curve CNR, circle CNR, this curve, and there is graph there.
There's no difference.
Graph and that.
Yeah, so okay, the difference is I can use this grafted list as an input into anything, while grafting here would mean that I have to graft and then graft and then graft here. Right? That is a difference. I use both. There's one is not better than the other. They are useful when they're useful. Pardon? Here, you can't like I'm just trying to show you the graph component, okay? There's no the point is like what if I needed a flat version of the point, right? I've got it. There's by the way, there's so many ways that you can approach a problem. So and none of them are the right way or the wrong way, right? There's yeah. Yeah.
Yeah, but I think that's fine.
Are we all good? No. Huh? No, it's not. I have a nice little lesson about graft and what it does, and we'll go through it. Okay. It is understanding graft properly is my definition of becoming intermediate at Grasshopper. Okay. So we're beginners at the moment. So we don't have to know. It's all good. Okay. Good? Not good. Yes. Yeah.
I kind of like the sign. I hate how it is. It's fun. Yeah, why does it look like that all the time now? Anyway, I just don't do it like this. Okay.
The D.
The D.
You don't want to use icons? Okay, that's fine. No, that's fine. You can use it's fine. Yeah, don't need to force you to do it that way. But that's how I'm just explaining that's how I'm gonna use it. Okay. I think we're all ready for the next step, right? What was the next step? We're pretty much done if you think about this as like a circle, right? Just a single circle. But if I'm doing like lots of trees, something looks a bit off, right? Which is randomness, right? Now we can approach this a few different ways, right? The first randomness that we're going to tackle is the rotation, right? So we're going to rotate these. Where do you think I'm going to find rotate? Exactly. You can see how easy my questions are going to be during class. Just leading you guys into being able to do this by yourself, okay? Now, transform is nice little has a nice little what's the word? References to maths, a lot of maths. We have affine transformations and Euclidean transformations. Euclid is this very famous mathematician and he came up with quite a lot, like a lot of the functions that we are going to use to transform things. A Euclidean transformation is something that does not modify the essential makeup of the original object. So things like move, the term move within Euclidean is translate. So this is translation. I'm moving it in space. Rotation, orientation. I'm not changing the makeup of this. It's not changing in scale. It's not changing, like it's not flipping or anything like that. So anything that is just taking an object and moving it to another location, maybe changing its orientation or rotation, you will find that in Euclidean transforms. Things like scaling and mirroring and morphing, you'll find those in affine transformations. Okay, so that if you have a look here, you can find scale, non-uniform, shear, box mapping, projecting. So projecting sounds like it's gonna take the object and move it, but what it will actually do is squash it so that it's like completely flat on the plane. Those are affine. We are doing a rotation, so we're going to find that in Euclidean. Cool. We'll come out of this with a maths degree as well. Now, just to simplify this, we're also going to use another type of transformation. You'll find this in the utilities. It's called group. This is getting tricky. Maybe not. No, we won't group. We don't need a group. Okay. Oh, this is getting tricky. Am I going too far? Far with the branches? Do you think? Okay. I'm going to add one more complicated step into this, and I'm not going to explain what it's doing. I want you to grab this guy. Actually, you won't have that guy. This guy. Grab this component called shift paths. You will find it here. Wow. Something cool? Okay, cool. Shift paths. I got really excited when I found this component. I started using Grasshopper before this component existed. And when it got brought in, I was like, my life has changed. It's so good. We want shift paths. I'm not going to explain this. You're just going to have to deal with the black magic that I'm giving you. What I want you to do is somehow type in the number -1. You can do that via a panel. You can do that via a number slider. You can do that via grabbing an integer parameter and changing that to -1. Point is, we need that to say -1. Pardon? Okay, cool. And what we're going to do is we're going to take the output of those shift paths and we are going to rotate them. There is an option for the angle and there is an option for the plane. So we are going to use the points as the rotating plane. And we don't want to use the ones that aren't grafted. We want to use the grafted points as the rotation plane. What that'll do is it'll give each of those guys a nice little rotation.
Is there a way that you have to do wires into something?
No. There is. You can do this. You can double click them and make relays everywhere and does that help you? So you can chuck a number slider in there if you want. And that'll change the rotation. Unless I'm going too fast. Am I going too fast? Does anyone notice something weird about my rotation? I'll just hide it. I'll hide these ones. Weird's the wrong word. Can anyone see the relationship between what I'm putting in as a rotation number and the output? Yeah, so I'd put in the number 1, and look, it's rotated like maybe almost 45 degrees, right? So the input of this is receiving angles as radians. Most humans don't think of angles as radians. They usually think of them as degrees, right? So some components that have angles in them, you can right click them and you can convert them to degrees so that they take degrees. So in here, I can change my number from 1 to 360, and I get a full 360-degree rotation from that. Just hide the ones you don't want to see. You good? Wolf.
Old.
What, 20? 20, 21?
Architecture, something.
Yeah,
Old in architecture.
21 in architecture. That's not old.
Making me.
Imagine working in the industry for 12 years.
Don't.
Okay. Now, trust me, this is not just good for trees, okay? You can do other things. Definitely. You can do stadiums, so it should be able to do everything. Cool. Okay. So this is not solving my problem, right? All it's doing is it's rotating stuff. It's not rotating it randomly. Okay. So we can we can generate random numbers in different ways. The core way of generating a random number, you can find that in set. And it is this cat in a box, and I think a lot of you might get that reference nowadays. But there is a cat in the box, and it is referring to uh, an uncertainty principle. So Schrodinger's cat. So there's a random chance the cat can be alive or dead. That's what it's referring to. The randomness is it's going to produce a number between 0 and 1. Okay. So rather than using this number slider to rotate, we can use the random generator to make a random number, but we want that random number to between 0 and 360. So very just to skip over a lot of object types, because it takes a range, but if we plug the number 160 into that, it'll produce a random number between 0 and 360. The n value is the number of numbers you want it to generate. So if I told this thing to generate 10 numbers, it will produce 10. And then the final number is the seed. Most of you who play video games and you play things like Minecraft, like a lot of you have played Minecraft, there's like reference to a seed, right? The seed is a term that is used for random number generation. Random numbers aren't actually random on a computer. Computers can't be random. All we can do is sort of fake randomness. And what it's doing is it's using the CPU to access, it's accessing the CPU at certain points and getting a random number from that, right? So right now, if you're doing this, I just want to double check. Is everyone getting the same random numbers as me? Is everyone getting 277, 145, 59, 354, right? So the randomness is being selected from this sort of wide list of randomness, and it's being controlled by this seed. And because you're using the same seed as me, too, you're getting the same randomness as me. That is not true randomness. If it was truly random, everyone here should be getting different numbers to me, right? So the way you do that is by just putting in whatever seed number you want, and you are going to get a different set of random numbers. Okay? And that's how Minecraft works for those of you who want to know. So you can take a number from someone else's Minecraft server. So they might be using seed 54. And if you put that 54 into your Minecraft, you will get the same starting world that they start with. Cool? Even though it's random, there's a starting seed. Cool? Just a little tidbit. I don't think you need to understand the complete mathematics of that, but that's why you would be getting the same randomness as me. Now, if I plug this directly into the rotation, it is going to cause a bit of a mess, right? Maybe it's a mess that we like. Maybe it's serendipitous that it's done that. But what we need to do for that not to be messy is we just need to run that through a graph, just like we did with the points. Did that graph work? Oh, okay. And then there's one other thing, and I'll just show you what that is. So I'm generating 40 numbers, random numbers, when I've only got 8 trees. So what we want to do is we want to only generate the number of random numbers that we have of trees. We don't want any less or any more. So within set, there is a component that lets you look at the length of a list. You can see that, where is it? I've lost it. List length. So plugging my original points in, because the original points is going to tell us how many trees we've got. So that's going to tell me 8. I can use that as my input to generate the random numbers. And there we have a completed script that we talked about on the board. Cool. So we're looking at the length of the list of the points. So we've got 8, or you've got however many that you drew. And it's generating 8 random numbers and using them to rotate those lines. Here, I will do this. For those of you who feel like they are at this point, have a go at making the trees a random size. Okay, it's almost 2 o'clock. There's no way we're gonna do anything more than this. What do you want me to focus on? All good. Working? Is it working?
I'm trying to scale it.
Okay. Oh, I see. I think I know what you're doing.
Like scaling it as a
Right.
group.
So what's the input for scale? What are the inputs
Oh, GCF.
and what do they mean?
Oh.
What do they mean? If you mouse over them, they'll tell you.
Geometry, yeah, center and factor.
Right. So
Center. Yeah. Oh my god.
if you're going to use any center point, use the grafted one. Don't use the original. Use this one.
Yeah, that-
Use this one. Is everyone good? Those of you, do you want me to show you guys how to do the scale, or do you want to have a stab at it yourself? Of the tree. You want to try it yourself? Okay. What I'll do is I'll wait a few minutes and then I'll show everyone.
What's that? What
The factor. The factor. Yeah.
Okay.
I know how you're doing it, but it's not how I would do it.
Well, here we are.
Yeah. But I know how you're doing it. I know how you're doing it. It's probably the right way to do it. It's not gonna work.
It's not gonna work.
No.
Oh, okay.
But you'll see. I want you to go down that path first. By the way, guys, this is going in the portfolio, right? Yeah? Cool. Also, if for your reference, you can always use these panels to write notes. Raft did this. What? You know, you can leave notes in your script, and as well there's some nice little there's this thing called a scribble, I think. No, yeah, scribble, which you can also double click and put text in. There are these, you can group stuff in the grasshopper, so Control G, that that'll put those components in this little box. You can change the color of that box. You can name it. Bake me. Right? So there's a few ways that you can organize your scripts as well. What else? Oh, and you can also see there's a little pen here. You can draw stuff in the Grasshopper script if you want as well. If you want to keep those types of notes. the fun thing about this one is I can do this. Huh? Question? Nice work. Okay, I feel like as everyone people are trying to do the scaling, right? Did it work? Has it been working for people or not? Nah. Why? Oh, you haven't been doing it. Okay, I'll probably do the way that you're thinking, and I'll explain why it doesn't work. So you can try and scale this, right? And I'll grab the center points as the things to scale. And if I like even just without the random numbers, it doesn't work, right? Because I'm not I'm only scaling those lines. I'm not scaling the circles. So what you can do is you could come back to this circle and change its radius with a random number. Yeah, good. Okay, we'll do it. Just it doesn't if it doesn't work, just follow along. So what we'll do is I'll just grab a new random number component. There we go. And very quickly, we will plug in the number. We will graft it, and it's going to produce a bunch of very small numbers, right? It's going to, because at the moment, it's only producing a number between 0 and 1. But my trees have to be 39 units or whatever, right? So if you plug a number into the range will by default go between 0 and the number that you've plugged in. But we probably don't want it to be 0. We want to set a minimum to that range as much as we want to set a maximum to the range. So ranges are controlled through maths, and they're controlled via this thing called a domain. So we can construct a domain. I'll show you where I get it from in a sec. Like this. So domain, you can find construct domain there in math. And what that takes is a minimum and a maximum. Plugging that into the random, that's now controlling the smallest number that random can produce and the largest number. And we can actually run another mathematical function on that to make that central branch. So we can take that random number and multiply it. So you can see here I've got multiplication. We're going to multiply that by a slider. And that will give us control over that center point as well. So that's always going to be, in my case, 15%. of the larger one. Okay, I'm gonna redo this all, okay? Because I can feel people. I can feel that I've gone too fast. Okay, but what that's done is it's allowed me to create that. So I'll just very quickly just chuck in some more points. Boop. And there we've got a bunch of random trees on those points. Ooh, we've got some repetition. Oh, it's because I've got 2 points there. Cool. Okay, so just to repeat what I did, I'll delete that. And I'll get that number slider back. So we're going to create a new random component. And rather than it, we're going to use the same length. So we're going to measure the length of this list. We could use that component, but I'll just copy it. And then rather than the number being from 0 to 1, we can control it via this thing called a domain. So you can find that under math in domain. It's construct domain. You can put in whatever number you want for the minimum and the maximum. Plug that into the range input for the random. And then that random number is what we can use. We'll need to graft it. So we'll graft it and then have that plug into the radius of the initial circle. Now that could be enough, but if you also want to control the size of the inner circle by this random number, we're going to take a multiplication. Okay, sorry, yep. Yeah, I'll stop here. Okay. Please, if I'm ever going too fast, tell me to slow down. Okay. You're more than welcome to interrupt. Yeah. Yep. Sorry. Okay, so what's happening is a lot of these components are doing graphs. They're doing graphs as part of the function. So you grab a pen. Outside. So it's put these because of the way that graph works. But we want the 2 lines to be treated the same in that same group rather than line treated. So what's happening? That's the part of the front. And what we're doing is we're removing the one second on the front, which is what the last is doing. And then the number that we're putting in which direction it is. The negative one is shifting from the left to the right. Right, sorry. And with the positive on the right. So this path explanation is opposite.
Like I think so if you have a set that has multiple points, it creates like a separate thing for everything.
Yeah, a lot of people think
So I think if you just have the graph, they will all just
you know, grasshopper at all.
I think with the graph, it makes them more separate objects.
Nuclear, take the data, and just push it all into one.
Like with,
Right?
yeah.
Whilst
I think that's what it means, because it says it creates a separate branch in each part.
you guys, okay, so you can point that
Well,
the other.
Oh, I'm trying to make it as separate as possible. It's just not.
So these two are now.
No, but then like you can't like sometimes when they overlap too much, you can't see which one is going into that. If I have something in here, it's like that's sort of it kind of like
We will get to that.
Yeah.
Okay. By the way.
Yeah,
this
yeah,
part-
it's like it's not really. I think
This is just.
what do you do? So I can double.
Graph takes each individual item in a list and creates an images that each it creates their own separate branch for every item.
Are you doing?
Not that has no, yeah, no, it's, okay.
She's on Me too.
Oh, really? So that's.
Oh,
No, she is about to. I don't have Saturdays on it.
yeah, of course not. Yes.
That's like double what I've got.
It's not too bad. I last semester I worked Friday as well. Like if I like was really wanted to earn money and was as crazy as that, I would work Friday. I can't be.
So you drag it over, it's going to.
Yeah, and like
I need the time to like. Are you doing interviews?
well, I'm doing a one semi-structured expert. I'm not doing anything.
Now,
else really. Mine's not really good.
Now that's pretty effective, right? Now, what?
Randomness of one, so.
Yeah, nothing, right?
It's actually I like to
This block is looking at the things that are in the front.
But it was that. Wait, you said it's a non word.
Okay, so there is a slightly more advanced version of the graph.
where it is.
This lets you control how large. This one's not. To the side. Yep. Now, check that out. Okay. Okay. Yeah. Okay. Yeah. Yeah, no worries. Okay. So, yeah. And if you come back, it's all really important. Oh, Sam, this- Cool. It's 1:52, so technically we've finished in 8 minutes. Can those of you who don't have a group email me? My email's on the front cover. Email me what you want to interested in, and I'll connect you with someone. Okay. Cool. And so those of you, not those of you, everyone, without getting too deep into Grasshopper, through your own process in that group, come up with a stair design. Okay. Apply the aesthetic to it with a stair, any stair, and the more interesting the stair, the better, because you are kind of setting a rod for your back, because then we're going to try and code that stair with Grasshopper. Okay. And that is, we are aiming for the stars. Okay. So if you don't get there, it's fine, but we're trying to push ourselves further, and you'll be rewarded for that. Question?
Oh no, I'm just lost.
Okay. Cool. So it's completely contextless. It's a stair. All it's got to do is get you from point A to point B. It could have multiple point Bs, but like it doesn't matter what the site is or where it is. It's just a stair. It's going to be floating in space. So go nuts. Go nuts. We're going to have an issue with the designing with country with that one. So they're going to come talk to us in the second assignment where it's actually got a site. Cool.
Don't worry about Australian standards.
No, no. It's a design. It's a stair design. Yeah. Don't.
Uneven treads.
If you want to design that, go for it. Yeah.
So we're not modeling it, we're just designing.
You can.
Oh, okay. Not using Grasshopper.
We are going to use Grasshopper, but I would like you to start the process,
Okay.
right? You're going to decide on your TechnoPunk,
Yeah.
right?
Yeah.
So get started with it. You don't need Grasshopper to get started on that.
Yeah.
But we're going to try. I'm trying to give you guys the puzzle pieces to actually drawing it with Grasshopper.
Like for example, are we working with Grasshopper to make us there next week? Is that like
We will start learning things next week that will help.
So we're not expected to like go off and
I'm not like you've got until week 6 to have a finished stair design.
On Grasshopper. Okay, I understand.
We'll see.
Oh, in January. Okay.
Okay. So start your process. Yeah.
So are there deliverables for next week? Like, what are we coming to class with? Just like,
You've chosen a TechnoPunk
and started on it.
and you've started on it,
Okay.
and that way, I will be teaching. So next week we'll be teaching patterns and sequences. Which so I might even we can talk about object theory. Hang on. Yeah, we've completely skipped over some of these. Object theory versus design Python. No, we'll be doing sequences and pattern. And that'll hopefully start you guys off with being able to do like pattern making in Grasshopper. So like I use that to make stairs, I use that to make trusses, I use that you can like look around bricks, like anything that uses patterns and sequences is going to show up in that. Cool. Yes.
Okay. I'm going to do something else. That's how it was.
Yeah.
So I think I somehow have too many points. That's one of them.
So wait, like,
But it's so difficult.
well, yeah, I guess we can.
And also, I lost my
I mean, that's what I'm saying. Like, oh, so I mean, yeah, I think you know about it. I don't really know how to do step. I just make one and then I use the phone. Oh.
You now.
I'll just explain this.
I mean, we choose the same one.
Okay, and
But you have to do the same. Down. It's okay. Well, I mean, who knows what's happening with that.
I should have gotten rid of that one together, yes. They were there.
Okay, which ones do you want to do? Do you want to do like an industrial bar like this? Wait, I was gonna say.
Guys, if you're having trouble, email me during the week. Like if GitHub's not working or anything, for now, I don't have access to the canvas. I will hopefully in a few minutes' time, but just email me, okay? And then we'll eventually move to canvas when that's good. Cool.
So I have some questions.
Yeah.
Questions. The stair design is in pairs. Like
Yes,
you're
it has to
expecting
be.
one for the two of us, right?
I am.
Yeah. Okay. Cool. And then next week, is this class at 9 or at 8? Because I know
It's lecturers at 8,
there's no lecture next week.
isn't
The
it?
majority of the classes are on 5, is it?
Then it's 8 here.
8 here. It is 8 here. So it's good. Okay,
That's
cool.
good. That's a good thing. No matter what, today will start at 8, be it if there is a lecture or not.
Okay, cool. Sounds good. Okay, cool. Maybe, okay, so yeah, do you want to I'm leaning towards anime. I feel like this is
Like 50s style.
yeah,
Yeah.
like
Have you seen there's like what's it called? Oh, shit. Fallout.
oh yes, Fallout series.
Yeah.
Futurama, like
Yeah, yeah, yeah. Yeah, I am. Yeah, hang on, let me just stop this recording.